development in COVID-19 era, focusing on the chemistry aspect in energy, food, health, and environment.
To attract participants from all over the world, the Department of Chemistry, Universitas Gadjah Mada, collaborates with the School of Chemical Sciences, University Science Malaysia, the Royal Society of Chemistry, and the Indonesian Society of Chemistry. There are 4 keynote speakers in this conference from Indonesia, Malaysia, Japan, and Thailand. Also, there are 4 invited speakers from Germany, South Korea, Singapore, and Indonesia.
All presented abstract will be featured in the Book of Abstract. Selected works nominated by the committee will be published in the scientific.net, a Scopus Index Conference proceeding edited by reputable scientific boards. Before we start our session, participants should follow the conference guideline. First, participants are expected to be present in the virtual room no later than 10 minutes before the event starts.
Second, participants are expected to remain silent or muted until they're allowed to speak by host or moderator.
Third, participants are expected to ensure that they have enough bandwidth to participate in this conference.
Fourth, participants are not allowed to record the program in any forms because the content of this conference is protected by copyrights.
Fifth, participants are expected to use their full name on the account used in accordance with the name during registration. Participants are required to change their usernames by adding a parallel room code. For instance, Adi Herman will be engaged in a gamma parallel room. Then he should change his username as G_Adi Herman.
Six, participants who are registered as non-presenter are allowed to choose which breakout room to join during the parallel sessions. That is the information of the conference. The session will begin shortly. Thank you.
Dear participant, please change your username as accordance to the format. User parallel room code underscore your name during the registration. Thank you.
Cek.
Dear participants are expected to use their full name on the account used in accordance with the name during the registrations, and participants are required to change the user's name by adding a parallel room code. For instance, Adi Herman will be engaged in a Gamma parallel room, then he should change his username as name Adi Herman, username G_Adi Herman.
Good morning, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Welcome to the 4th International Conference on Chemical Sciences. First of all, let us praise to God because of His mercies and blessings, so we can gather on such a beautiful occasion this morning. My name is Fadli.
And my name is Katie.
It's been a great honor for us to be standing here as the Master of Ceremony over the next 2 days.
Before we proceed with the program today, we would like to express our sincere gratitude to Rektor of Universitas Gadjah Mada, Profesor Insinyur Panut Mulyono MNDeng,
Dean of Faculty of Mathematics and Natural Sciences, Universitas Gadjah Mada, Profesor Dr. Kuatriana MSc,
Dean of School of Chemical Sciences, University Science Malaysia, Profesor Dr. Rohana Adnan,
the fourth ICCS 2021 Chairman, Dr. Roto M. Eng,
our keynote speakers, Profesor Dr. Sri Juari Santosa M. Eng from Universitas Gadjah Mada Indonesia, Associate Professor Oh Chuan Wei from School of Chemical Sciences, University Science Malaysia,
Professor Yuichi Kamiya from Hokkaido University, Japan,
Professor Pranut Potiara, PhD from Chulalongkorn University, Thailand,
and our invited speakers, Dr. Bambang Purwono MSc from Universitas Gadjah Mada, Indonesia,
Dr. Renat Anna Artati MSc from Helmholtz-Zentrum München, German Research Center for Environmental Metabolomics and Proteomics Core, Germany,
Professor Yonggun Ko from School of Material Science and Engineering, Yongnam University, South Korea,
Associate Professor Judeh Zahir from School of Chemical and Biomedical Engineering, Nanyang Technological University, Singapore,
and to our sponsor, PT Spectacrom Indonesia,
PT Teknolab Indo,
Indonesian Natural Dyes Institute, Universitas Gadjah Mada,
PT Gincraft,
PT Ditek Jaya,
PT Era Mitra.
And the Excellencies presenters, all participants, ladies and gentlemen.
Ladies and gentlemen, please allow me first to read the agenda for today. The first agenda is the opening session, which the current session is, then followed by the playing of Indonesia and Malaysia national anthems, also the opening speeches. The second agenda is a plenary and parallel session. Also the last is the closing sessions. So ladies and gentlemen, our next agenda is playing the Indonesia and Malaysia national anthems.
Ladies and gentlemen, we are going to start the welcoming speech. The first speech will be delivered by the chairperson of the 4th International Conference on Chemical Sciences 2021. Without further ado, we would like to invite Dr. Roto M. Eng to deliver his speech. Please welcome Dr. Roto.
Assalamualaikum warahmatullahi wabarakatuh. The Honorable Rector Universitas Gajah Mada, Professor Panut Mulyono, the Honorable Dean of Faculty of Mathematics and Natural Sciences, Universitas Gajah Mada, Professor Quatriana, the Head of the School of Chemistry, University Science, Malaysia, Professor Rohana Adnan, distinguished guests, invited speakers, participants, ladies and gentlemen, good mornings. And again, Assalamualaikum warahmatullahi wabarakatuh. On behalf of the organizing committee, I'd like to welcome you all to the International Conference on Chemical Sciences 2021. This is the occasion of the conference series. This conference is jointly organized by the Department of Chemistry, Faculty of Mathematics and Natural Sciences, Universitas Gajah Mada, and the School of Chemical Sciences, University Science Malaysia. To reflect the current situation, we propose a theme advancing innovation in chemical sciences for sustainable development in COVID-19 era. This time, we have about 60 contributing speakers, a slight increase from the previous conference. We appreciate your contribution to this forum. However, due to the COVID restriction, we should organize this forum virtually. As indicated by your paper submission, the COVID limitation does not seem to deter us from doing research and innovation. We believe that we could advance science and technology in the chemicals area through research and publication, in which we are passionate and happy to do so. Please note that selected papers from this conference are to be published in key engineering materials of Transact publication. The organizing committee is grateful to have full support from the University of Gajah Mada, both technically and financially, to make this event happen. It would be impossible to organize this such important scientific meeting without tremendous support from everyone in the organizing committee. We wish to thank you all for all devoting countless hours of diligent work to make this event reality. Special thanks should go to everyone in the scientific committee and reviewers for reviewing the manuscript in timely manner. We do hope that this conference will provide an inspiring experience for you to develop chemical knowledge and other related fields. Have a great seminar and see you at the upcoming scientific events organized by the Department of Chemistry, Gajah Mada University, and School of Chemistry, University Science Malaysia. Assalamualaikum warahmatullahi wabarakatuh. Back to you.
Thank you, Dr. Roto, for the speech. The second opening speech will be delivered by the Dean of School of Chemical Sciences, University Science Malaysia. Without further ado, we would like to invite Professor Dr. Rohana Adnan to deliver her speech. Please welcome Professor Rohana.
Thank you to the chairperson. Is it okay? Can you listen to me?
Yeah.
Okay. Thank you to the chairperson, the honorable guest, Rector of University Gajah Mada, Professor Panut Mulyono, Dean of Fakultas Matematika dan Ilmu Pengetahuan Alam Universitas Gajah Mada, Professor Dr. Quatriana, the Honorable Chairman of ICCS 2021, Dr. Roto, distinguished speakers, colleagues from UGM and USM, dearest participants, ladies and gentlemen, Assalamualaikum and a very good morning. I would like to express my sincere gratitude and also to take this opportunity to welcome all the distinguished speakers and participants to the 4th International Conference on Chemical Sciences, ICCS 2021. It is a great honor for USM, University Science Malaysia, through School of Chemical Sciences, that this time we are the co-hosts for this conference. I would like also to congratulate and thank the ICCS 2021 committee members led by Dr. Roto for their hard work to ensure the success of this conference. To all friends and participants from UGM especially, I would like to extend our salam persaudaraan from Penang, Malaysia. I sincerely hope that this conference will be a great platform for successful collaboration and networking for all of us. I also hope this conference will bring us together to share, to discuss, and to innovate, not limited only in the field of chemical sciences, but also for the overall sustainable development during the COVID-19 and the post-pandemic era. I would also like to take this opportunity to announce our 8th International Conference for Young Chemists, which will be held in Penang, tentatively in August or September 2022. So we are looking forward to welcome all of you to Penang. Thank you to each and everyone for being here with us today. Have a great conference time wherever you are. Thank you. Assalamualaikum. And a very good morning to everyone. Thank you.
Thank you, Professor Rohana, for the speech. Next, we are going to listen to the opening speech delivered by Director of Universitas Gadjah Mada. Please welcome Professor Insinyur Panut Mulyono, MNDM.
Distinguished speakers, participants, ladies and gentlemen, on behalf of Universitas Gadjah Mada, it is my pleasure to welcome you virtually to Yogyakarta for the 4th International Conference on Chemical Sciences, ICCS, jointly hosted by the Department of Chemistry, Faculty of Mathematics and Natural Sciences, Universitas Gadjah Mada, UGM, and the School of Chemical Sciences, University Science Malaysia, USM. This conference has a role to connect the scientists across the continent. As we know, the community has never moved faster without advance in science and technology. The universities have gained a reputation of pioneers, pushing the boundaries between academics and professionals to help discover new knowledge for the benefit of humankind. With scientific conference series, UGM built upon this mission, holding scientific gathering for the brightest minds from Indonesia and the rest of the world to share the research outcomes. Through international collaboration, the series of conferences have been a success, shaping the development of scientific network, increasing visibility of prominent authors in publication. We are honored to have many people who will join the conference. The response from authors and participants to the ICCS 2021 has indeed been remarkable, even though we are in the COVID-19 pandemic. We are indebted to the speakers for sharing their knowledge and great discussion during the conference. Special thanks are extended to the organizing committee members from UGM and USM for their tedious work organizing the ICCS 2021. And finally, we would like to thank all of the conference participants who will contribute to making this the most memorable ICCS. I'm sure you all will have a fruitful and rewarding exchange of ideas in the next 2 days. I wish you all a successful ICCS 2021. Thank you.
Thank you, Professor Pandit Bueno, for the speech. Excellencies, presenters, participants, ladies and gentlemen, now we are going to listen to the opening speech from the Dean of Faculty of Mathematics and Natural Sciences, Universitas Gadjah Mada. And afterward, we would like to request the Dean to officially open the 4th International Conference on Chemical Sciences 2021. Ladies and gentlemen, please welcome Professor Dr. Kuat Triana.
Assalamualaikum warahmatullahi wabarakatuh. First of all, let's thank God, the Almighty, who has given His grace and gratitude so that the 4th International Conference on Chemical Sciences, ICCS, will be with the theme of advancing innovation in chemical science for sustainable development in COVID era can be held successfully. On behalf of the Faculty of Mathematics and Natural Sciences, Universitas Gadjah Mada, it is my pleasure to welcome you to this year's conference, which is jointly hosted by the Department of Chemistry, Universitas Gadjah Mada, and the School of Chemical Sciences, University Science Malaysia. Despite the COVID-19 pandemic limitation, this conference has received significant attention, not only from the researchers from university, but also from many research institutions who contribute in the meeting. I express my highest gratitude and appreciation to the keynote speakers, invited speakers, and all presenters. I believe that this conference will be the source of innovative ideas, concepts, and breakthroughs in the development of chemical sciences. Moreover, this conference will help build a global network while learning the latest advances and the development of research in chemical sciences despite being in this pandemic situation. Congratulations and sincere thanks to the organizing committee led by Dr. Rota on the tireless effort and hard work in ensuring that the virtual conference is conducted smoothly and successfully. To the presenters, I wish you all the best and have a tremendous scientific gathering. I hope all participants will find the event fruitful with a nice moment of knowledge and experience sharings. Lastly, by reciting Bismillahirrahmanirrahim, I declare that the 4th International Conference on Chemical Sciences 2021 is officially open. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Professor Dr. Engineering Kuat Triana MSc, for opening this event. The next agenda is the photo session. To the keynote speakers, the dean, directors, as well as other participants, please take position and enable your camera. So there are 8 slides in this room. So we start from the first slide, okay? Okay, everyone ready? Let me count 1, 2, 3, and then say cheese, yeah. Okay, 1, 2, 3. Cheese, the first slide. 1, 2, 3, the second slide. Okay, 1, 2, 3, the third slide. 1, 2, 3, the fourth slide. 1, 2, 3, the first slide, sorry. 1, 2, 3, smiles, the sixth slide. This is the seventh slide, 1, 2, 3, smiles. Okay, this is the last slide, 1, 2, 3. Okay, that is the last slide. As we are finished the opening session, there are promotion video. There's Universitas Gadjah Mada promotion video, so let's enjoy it first. Thank you.
Universitas Gadjah Mada, or UGM, is a public university renowned as the People's University, which strives for and puts forward the interests of the citizens and nation of Indonesia. As a higher education institution that has long been recognized by the society, we are proud of our timeless and tireless dedication to the nation. By cultivating, implementing, and leveraging education, research, and community services, which constitute the salient objectives of Indonesian higher education, or Tridharma, we remain committed to incessantly promoting the values of Pancasila. We exert the utmost effort to protect Indonesia's sovereignty in accordance with Pancasila ideology and the 1945 Constitution. As a world-class university, UGM is devoted to the interests of the nation and humanity. We conduct research, provide education, and deliver community services by enhancing knowledge that benefits the community, the nation, and the world. We have been learning from one another and get stronger together since we believe that knowledge is not useful unless it is shared with others. The learning process will never cease developing. At UGM, we learn by continuously exploring sciences, learning from history, observing the present, and researching for the future. We always work hard and never give up. The learning and research processes at UGM continue to run together and explore state-of-the-art innovations. To create a convenient, environmentally friendly, and pollution-free green campus, UGM has built a wisdom park that substantiates the teaching and learning process. The park per se is open to the public. UGM has also developed drinking water facilities throughout the campus, provided by Drinking Water Supporting Unit. This system is harnessed by the entire academic community of UGM. As the manifestation of its teaching endeavor, UGM operates various field laboratories for educational and research purposes. Furthermore, UGM has established and run a science technopark as an embodiment of its capability of inventing and commercializing a myriad of innovative health products, ranging from medical devices, herbal medicines, and healthy food.
There are now more than 118,000 cases in 114 countries, and 4,291 people have lost their lives.
2020 has been a tough year for anyone, and it is no exception for UGM. Campus activities are abruptly halted, student activities on campus are annulled, and everyone is forced to work. worship, and study from home. Lecturers have no choice but to learn how to teach effectively using the Information and Communication Technology or ICT. Learning and research on technology are strongly supported at UGM, and in fact, we have conducted various cutting-edge technological research. Community Service or KKN is one of the most important courses to complete the study program, which will be undergone by University of Gadjah Mada or UGM in 2020 while adapting online courses system. Supported by the Ministry of Education, UGM will continue its service within the society across Indonesia during the pandemic issue. Lecturers and researchers at UGM continue carrying out basic and applied research in many realms. For instance, studies in the health sector to cope with COVID-19 are being encouraged and accelerated as a form of UGM's commitment to mitigating disaster using scientific methods. One of the most innovative inventions regarding to mitigating the COVID-19 is Genos, a screening tool or early detector of patients exposed to COVID-19, which is able to identify the symptom through exhale within 80 seconds. Genos is highly reliable. It has a number of advantages as a COVID-19 fast detection tool. Its sensor is able to detect more than thousands of patients in the long term, while providing relatively fast results, non-invasive and affordable. In addition, its usage also applies non-rebreathing mask and disposable HEPA filter. Those challenges somehow direct or even force us to innovate and modify approaches. Success is a journey which necessitates smart work through learning, studying, and sacrificing. Despite all that, most of all, we love what we do.
Dear all participants, I would like to remind you to change your username by adding a parallel room code. For instance, Adi Herman will be engaged in a Gamma parallel room, then he should change his username as name Adi Herman, username G_Adi Herman.
Okay, after seeing the promotion video of Universitas Gadjah Mada, now we are going to see the promotion video of University Science Malaysia. Please enjoy.
University Science Malaysia, which is founded in 1969, is among the oldest institute of higher learning in northern Malaysia. The School of Chemical Sciences is based in the main campus on the Penang Island. Dating back to 1970s, when the University Science Malaysia was founded, the School of Chemical Sciences made its mark as one of the 3 pioneer schools. During that time, Professor Francis Mossing was appointed as the founder dean of the School of Chemical Sciences in April 1970.
All our undergraduate programs are recognized by the Malaysian Institute of Chemistry, a professional body for chemistry in Malaysia. These programs have also received accreditation from the Royal Society of Chemistry, UK, early 2016. As a research university, the school is equipped with various specialized equipment, lab facilities, including glass blowing facilities. As such, we are able to offer master and PhD programs to local and foreign students. Our students are very fortunate to have overseas experiences through our collaboration with foreign universities, especially Université de Lorraine, France, and Nagorka University of Technology, where we offer double PhD programs with these universities. Apart from the academic and research programs, the school is very much involved with community work through various activities organized by our chemistry society and alumni with schools and community at large. We take pride in our micro-scale experiments in promoting green chemistry as part of our activities with schools and summer programs for foreign students.
In addition, our academic staff and students have received several awards nationally and internationally in recognition of their achievements in their research. Three undergraduate programs are offered by our school, namely Bachelor of Science in Chemistry and Bachelor of Applied Sciences, either Analytical Chemistry or Industrial Chemistry.
In this program, we also offer our students industrial experience by taking industrial training, and this is compulsory for our students in the Bachelor of Applied Science Industrial Chemistry. Students will graduate with the communication, analytical, and research skills required by employers. We also encourage students to take advantage of our international networks to broaden their experiences.
The lecturers from School of Chemical Sciences are very dedicated. They always help the student in their academic. They always share information and instill knowledge in students. And they always share their experience and also insight with the student in order to guide them further.
The staff and lecturers here are very supportive. For example, when I was the head of program for a program named ChemRock, the lecturers really helped me to prepare for the program. They helped me to decide on what experiment to be done on that day, what's the procedure and the apparatus, and many more. And if I have any doubts or questions, for sure they will be there to help me. And they really make me feel like I want to be them one day in the future.
My journey in School of Chemical Sciences has been amazing. The well-rounded and well-planned 4-year program has guided my studies throughout my time being here. Besides theoretical skills, USM is also a great platform to enhance my soft skills. One of my best experiences is joining the NOVA Research and Innovation Competition.
3 major postgraduate programs are offered by the School of Chemical Sciences. They are Master of Chemical Instrumentation by Mixed Mode, Master and PhD by Research Mode.
As far as our School of Chemical Sciences is concerned, our staff have involved in various research areas. Some works on interdisciplinary basis. It is the responsibility of the school to align this research field so that it will not deviate very much from the 5 main divisions in the School of Chemical Sciences. These divisions are physical, organic, inorganic, analytical, and industrial chemistry.
I'm taking out the active component from a plant and modify it, hoping that one day we can produce an anti-dengue medicine of our own.
I'm working here for past 3 years. My research is all about synthesizing nanomaterial, thin oxide. We are using a simple hydrothermal method without using any surfactant, organic template, and further calcination. So this material is very useful for gas sensor.
I choose USM because of their standards, quality, academic achievement in terms of learning.
The researchers, including the staff and students in the School of Chemical Sciences, have the access to various scientific instrumentation at the school.
In line with our university's vision and mission, The School of Chemical Sciences aims to prepare the students to face the future challenges, to empower the students to create their own career path and transform their social-economic well-being. Transforming higher education for a sustainable tomorrow.
Okay, after seeing the promotion video of School of Chemical Sciences, University Science Malaysia, now we are going to see the promotion video of Department of Chemistry of Universitas Gadjah Mada. And also, after that, we are going to see the promotion video of International Undergraduate Program that available in Universitas Gadjah Mada. Let's enjoy it. Thank you.
Di dalam kerendahan hati dan keramahan daerah istimewa Yogyakarta, Universitas Gadjah Mada menyambut seluruh insan bangsa dari seluruh Indonesia dan dunia internasional dengan fasilitas pendidikan terbaik. Dilengkapi dengan 18 fakultas, 2 sekolah, dan lebih dari 100 program studi sarjana, magister, doktoral, serta program profesi dan spesialis. Untuk mendukung kegiatan pendidikan, penelitian, dan pengabdian kepada masyarakat, Universitas Gadjah Mada juga menyediakan berbagai pusat studi serta laboratorium terpadu. Dengan tujuan dan harapan yang sama, program Magister Kimia Universitas Gadjah Mada hadir di bawah naungan Departemen Kimia untuk mendukung terciptanya sistem pendidikan, serta lulusan yang memiliki pengaruh secara nasional dan internasional.
Departemen Kimia Fakultas MIPA UGM didukung oleh 44 staf dosen yang terdiri dari 38 doktor dan 6 master. 12 diantaranya berjabatan fungsional profesor, serta ada 27 tenaga kependidikan. Fasilitas laboratorium yang kita miliki untuk mendukung riset antara lain XRD, kromatografi gas, kromatografi cair, AS, FTIR, TEM, elemental analyzer, dan lain-lain. Program sarjana, program magister, dan program doktor kami semuanya terakreditasi unggul oleh BAN PT. Khusus program studi sarjana terakreditasi internasional Royal Society of Chemistry, Inggris. Departemen Kimia memiliki banyak sekali mitra dalam dan luar negeri yang siap untuk mendukung kegiatan pertukaran mahasiswa, kolaborasi riset, dan dosen tamu.
Program studi Magister Kimia FMIPA UGM berkomitmen untuk menyelenggarakan pendidikan pada jenjang magister yang menghasilkan lulusan dengan kompetensi berwawasan nasional dan mempunyai paparan internasional. Dalam rangka mencapai tujuan tersebut, program studi Magister Kimia telah menjalin kerjasama dengan berbagai institusi pendidikan tinggi di luar negeri, dan kita mempunyai berbagai macam program, baik program exchange, kemudian kredit transfer, ya, kerjasama penelitian, dan lain-lain, yang tujuannya adalah untuk meningkatkan paparan internasional bagi lulusan program studi Magister Kimia. Saat ini program studi Magister Kimia FMIPA UGM mempunyai 2 program utama, yaitu Magister Kimia by Course dan Magister Kimia by Research, yang secara kurikulum pada tahun pertama secara umum mahasiswa dituntut untuk belajar mengenai mendalami pemahaman tentang ilmu kimia, kemudian studi literatur dalam rangka mempersiapkan kegiatan penelitian di tahun kedua. Untuk peserta program Magister by Research, jumlah mata kuliah yang ditempuh oleh mahasiswa jauh lebih sedikit karena fokus yang dibebankan adalah memang untuk kegiatan riset, sehingga diharapkan setelah lulus mahasiswa program Magister by Research ini punya kemampuan riset yang bagus, jumlah publikasi ilmiah yang memadai yang nantinya bisa dengan mudah mendapatkan beasiswa untuk melanjutkan ke program doktor. Saya mengundang kepada para mahasiswa lulusan S1 baik dari program studi kimia, pendidikan kimia maupun teknik kimia ataupun program studi lain yang berkaitan dengan kimia untuk bergabung melanjutkan studi di program studi Magister Kimia FMIPA UGM. Ada banyak pengalaman yang bisa Anda nikmati di sini. Kami tunggu Anda untuk datang dan bergabung di program studi Magister Kimia FMIPA UGM.
Untuk menciptakan akademisi, peneliti, serta praktisi bidang kimia terbaik, program Magister Kimia dilengkapi dengan kurikulum yang terbaharui, sesuai dengan perkembangan sains dan teknologi, serta komprehensif menyeluruh dalam lingkup dasar-dasar ilmu kimia serta terapannya. Mata kuliah umum yang mencakup pendalaman dasar ilmu kimia didukung dengan mata kuliah pilihan dari 5 minat, yaitu minat kimia organik, kimia anorganik, kimia fisik, kimia lingkungan, serta kimia analitik, memastikan terciptanya lulusan yang terkonsentrasi. Selain itu, lulusan juga dibekali dengan skill laboratorium dalam masing-masing minat melalui teknik laboratorium pada tingkat pertama. Pada tahun kedua program Magister Kimia, mahasiswa dipersiapkan untuk melakukan penelitian pada masing-masing minat yang dipilih sesuai dengan pilihan mahasiswa. Kegiatan penelitian serta perkuliahan dilaksanakan di bawah tenaga pengajar berkualitas dari perguruan tinggi terbaik nasional maupun internasional.
Hello, my name is Triyono, Dean of the Faculty of Mathematics and Natural Sciences, Universitas Gadjah Mada. Since its foundation in 1955, our faculty had constantly provided high-quality education while opening up new realms of science. Building on this tradition, in 2011, the faculty launched the International Undergraduate Program for Computer Science and Chemistry major. The program offers overseas as well as Indonesian students an opportunity to study and to obtain their bachelor's degree with international standard and excellent curriculum.
Assalamualaikum warahmatullahi wabarakatuh. I'm Solihun. I'm in charge in Office of International Affairs. There are two staff in here, me, myself, and also Ibu Retno that helped me to prepare documents related to international requirements. Our job actually is related to fostering of research and collaboration and community services, and also fostering of academic and student affairs. Faculty of Mathematics and Natural Sciences has two international undergraduate programs, which are international undergraduate program in chemistry and international undergraduate program in computer science. This program is taught in English, is fully taught in English, and from our data, the number of international student mobility increased by years, and this year the number is increasing than last year, and we hope in the future the number will increase and increase.
During the past recent years, with the support of the aforementioned design of the field of study and research interest, Chemistry Department of Universitas Gadjah Mada becomes the most prestigious chemistry department in Indonesia and a center of excellence in teaching and research in chemistry. Furthermore, an international publication has been a tradition of our supporting staff and students. Such a good teaching and research environment supported with the quality of human and non-human resources is an important factor to assure the excellent quality of the graduates.
I choose chemistry as my major because I want to understand how life is happening. For me, chemistry is the center of science. I learned a lot in chemistry. I learned how to cook a compound. I learned how to become an architect of molecule. I do a lot of research and I hoping do an innovation. I choose IUP because IUP offered to expand our skill and also our critical writing and thinking in international research environment. I also choose IUP because it offered students to go internationally, like its short-term and also long-term exchange. I joined Pasains FMIPA UGM community. It's a student association of environmental and adventure activities. I also joined Gadjah Mada University basketball team in UGM. In 2017, I joined several basketball competition, which is LA Campus League. We got runner-up in there. And also Borb Bapomi in Yogyakarta, we got first place.
Hi, my name is Ivan Rangga Pratama, and I'm a student of Chemistry International Undergraduate Program, Universitas Gadjah Mada. I study at Chemistry Program in Universitas Gadjah Mada because I think it's the best chemistry program that Indonesia have right now. And here I study wide varieties of topics, starting from the theoretical one up until the applicative one. Like for example, we study about cosmetics chemistry, we study about food chemistry, we study about energy in industrial and also catalyst in industrial field. So in Universitas Gadjah Mada, the chemistry study program offers you a wide variety of choices that you can choose. So I'm a final year in the bachelor program of chemistry in Universitas Gadjah Mada. And for my undergraduate thesis, I'm working on isoflavonoids, the synthesis of new isoflavonoids. And it's, hopefully it could be used for anti-cancer agents. And outside of academic activities, I'm also part of Gadjah Mada Chamber Orchestra in this campus. So to balance my academic life with my affective life, I play the orchestra. I'm also the conductor, the music arranger, and a cello player and a contrabass player in the orchestra. From that, I really earned many experiences from performing in one stage to another, from performing a small-scale concert up to the grand concert, and also performing in various concerts such as charity concert and also collaboration concert with other campus in Yogyakarta.
Hello, my name is Wahyono. I'm lecturer from Department of Computer Science and Electronics, Universitas Gadjah Mada. My research interests include computer vision, pattern recognition, machine learning, digital image processing, and software engineering. However, my focus on surveillance system. So in the surveillance system, I try to develop the system that can analyze the video footage from CCTV to identify behavior of human or other objects. For example, illegally parked vehicle detection, abandoned baggage detection, theft detection. So in abandoned baggage detection, I try to detect the abandoned baggage that abandoned by the human. In computer science international undergraduate program, I teach 2 classes. The first one is machine vision and the second one is programming 2. In the machine vision class, I teach the student the basic knowledge how to create AI-based application that can analyze the video or the camera. For example, face detection or facial expression recognition, and another that related with the face. Maybe we can also use the machine vision to analyze the video. This is the true video or this is the hard video. Meanwhile, in the programming class, I try to teach the student the data structure, the basic knowledge of the data structure. So I hope based on this knowledge, the student will understand how to use the data structure to do the programming to solve some problem. For example, for shortest path problem between one city to another city, they can use the graph data structure.
I chose international undergraduate program because in information technology, most of textbook and documentation are written in English. So it is important to know English as medium of communication. International undergraduate program also allows us to be exposed internationally. We can join student exchange, intern, or even international conference, and the department will support us. At first, I really didn't know much about computer science, but the further I go deep into the study program, the more I love computer science. A year ago, using technology, I wrote a program for students that has been used by over 1,000 students. The program made students' life easier by arranging their class schedule. And I'm very proud as a computer science student that by using technology, I can give impact to other people. I think computer science isn't just for somebody to learn, it is for everybody to learn. Because generally, computer science is not just about the technology itself, but it is about how to solve a problem. So everyone, please join computer science study program.
Many natural activity you can do in here in Jogja, such as hiking, like in Merapi in Jogja, or near Merapi there's Merbabu. Near Merbabu there's several other mountains that you can hike.
And I really do enjoy my stay in Yogyakarta for the last years. Here I get to watch many of the arts performance, ranging from the free ones to the one that we should pay. But then those experiences I could not get in Jakarta easily. In here we get to choose. We can choose any art stage that we want. It is available every day, every weekend, so just go and have fun in Yogyakarta.
I love studying in Yogyakarta because Yogyakarta is very beautiful city. In Indonesia, Yogyakarta is known as a city for students. And in Yogyakarta, there are many attractions from culture, and you can find mountains, and even you can find beach in Yogyakarta. And Yogyakarta is also supportive for students. The food is cheap, and you can find many cafes to study together with your friends. The street is also not crowded.
So we invite you to join us to have this international undergraduate program to get a great opportunity to experience in international exposure.
So as I know, currently the International Computer Science International Undergraduate Program has many collaboration with another university abroad. For example, from Japan, from Taiwan, from Australia, and from some European countries. So this is great opportunity to the program study of the computer science because the graduate profile will compete not only in national level but also in international level. So this is also a good opportunity to the student to have experience in the collaboration with the other student in another university, for example, in the student exchange or maybe the research exchange or maybe just the scholarship to the different university.
So don't be afraid to join chemistry in UGM. It's one of the best majors with international accreditation. It helps you to fulfill your dream to become international researchers.
So for those of you guys who are interested in studying in chemistry Universitas Gadjah Mada, go ahead and don't worry. People might say chemistry is daunting, people might say chemistry is hard and challenging and difficult, but then everyone here, starting from the lecturers, your friends, your seniors, are ready to help you to go through that in your life so that you will not have any kind of problem in finishing your degree here in Universitas Gadjah Mada.
By the edition of the IUP students, we hope it will strengthen our vision to be known internationally and nationally and excel in education, research, and community service, and to produce graduates who are competent in their fields, literate in information technology, entrepreneurial, and able to compete at both national and international level.
Excellencies, ladies and gentlemen, after the introduction video about Universitas Gadjah Mada and University Science Malaysia, we are now continuing our program to the main programs, which is to hear the keynote speech or lecture, which will be delivered by Professor Dr. Sri Juari Santosa MM from Department of Chemistry, Faculty of Mathematics and Natural Sciences, Universitas Gadjah Mada, Indonesia. The keynote speech will be moderated by Professor Dr. Rohana Adnan from University Science Malaysia. Ladies and gentlemen, please welcome our moderator, Professor Dr. Rohana Adnan.
Okay, Assalamualaikum and a very good morning. Our keynote speaker for the Our keynote speaker for the first plenary session is Professor Dr. Sri Juari Santosa. Let me first introduce our keynote speaker today. Professor Sri Juari Santosa is a professor in chemistry, Fakultas Matematika dan Ilmu Pengetahuan Alam, Universiti Gadjah Mada. Professor Juari Santosa is a UGM alumni, having graduated from UGM in 1988. He obtained his master's degree from Keio University in Tokyo, Japan in 1994, and then his PhD also from Keio University in 1997. He has been a professor since 2016 with more than 100 over publications and H index of 16 in Scopus and actually 20, I just checked yesterday, 20 in Google Scholar. Okay, his research interest is in green synthesis and application of material for valuable chemical recovery and environmental remediation. Professor Sri Juari Santosa has received many international recognition, and today I'm only going to read some of them here. He is the Indonesian National Project Coordinator for Persistent Organic Pollutants Monitoring and Management in ASEAN region under the United Nations University Institute for the Advanced Study for Sustainability, Japan. Professor Sri Juari Santosa is also a representative from Indonesia for the Excellence Center for Development, Cooperation, Sustainable Water Management, known as EXCEED, with a link to university in German. Our distinguished speaker this morning is also the International Advisory Board for Chemistry, an Asian journal published by Wiley and Wiley VCH. He is also the scientific advisor for the International Foundation of Science based in Sweden. Okay. Professor Sri Juari Santosa is also the editor for Clean Soil, Air, Water, a journal published by Wiley VCH. Okay, next. Okay, over the last 5 years, he has been keynote speakers and invited speakers to various scientific meetings, as you can see here. Next. And this is the last this year publication. Okay, this is only this year publication, not the rest. Okay, this is only the 2021. So you can see the prominent, the distinguished professor here. We are very lucky to have him today to share his experience and also knowledge with us. So next. In the last 10 years, he has published at least 3 books as book or as book chapter. Okay. Okay. So that is not the last, and definitely is not the last one. Okay. The presentation from Professor Dr. Sri Juari Santosa, is available in video presentation. Without further ado, please join us to listen to the presentation today entitled Nanoparticles for Colorimetric Sensors. Please welcome Professor Sri Juari Santosa.
Good morning, ladies and gentlemen. It is a great honor for me to have an opportunity to deliver my talk on the recovery of gold nanoparticles through in situ reductive absorption of gold-3 on organic acid functionalized magnesium aluminum layer double hydroxide. I am Sri Juari Santosa from the Department of Chemistry, Universitas Gadjah Mada, Yogyakarta, Indonesia. It is now widely recognized that nanoparticles have substantial advantages in enrich the core of many fields, such as from cosmetic, drug delivery to cancer imaging, and therapy, as well as antimicrobial. From the development of pollutant sensors to the engineering of ultra-active catalysts or photocatalysts and absorbent, and also from battery to energy harvesting solar cell and etc. Among nanoparticles, metallic nanoparticles have gained more interest and publicity because of their huge potential in nanotechnology. Although various types of metallic nanoparticles have been introduced, but gold nanoparticles, AUNPS, are one of the most intensively studied and applied due to their intrinsic physical, chemical, and optical features, which can be changed by altering their shape, size, aspect ratio, and environment, and also due to their stability against oxidation and degradation in vivo, which enable them to be used as potential therapeutic and diagnostic tools. However, the application of bare gold nanoparticle is subject to aggregation and agglomeration, which reduce their function and performance. In order to overcome these drawbacks, the employment of solid support having ability to reductively absorb dissolve gold-3 species to gold nanoparticles as host to facilitate uniform growth and well dispersion of gold nanoparticles without covering their surface should be beneficial. Literature survey showed that the recent existing reductive absorption method for gold-3 species may consist the use of hydroxyl functional group, phenolic OH functional group, and also carboxyl and phenolic OH functional group of these many types of different materials. Unfortunately, those existing reductive absorption method yielded non-uniform growth of gold nanoparticles, which is dispersed and entrapped in the matrix. As shown in this picture, just for the illustration. Here, we compiled our research activities dealing with the use of organic acid functionalized layer double hydroxide as host to facilitate a uniform growth and well dispersion of gold nanoparticles without covering their surface. The LDH used In our research group, magnesium aluminum LDH is the most frequently synthesized LDH. And the organic acid used to functionalize the magnesium aluminum LDH are still limited to ascorbic, gallic, and salicylic acid. Magnesium aluminum LDH used in our research groups is frequently synthesized through co-precipitation method, in which a decarbonated solution of magnesium nitrate and aluminum nitrate into this mixed solution, a decarbonated sodium hydroxide solution is added dropwise and under nitrogen atmosphere and continuous stirring so that the acidity of the medium reach pH 10. And the form magnesium aluminum LDH at this pH 10 is a white precipitation which is stable from the dissolution at pH 3 or at pH higher than 3. X-ray diffractometer characterization of the synthesized LDH show that the synthesized LDH have three main peaks. Three main peaks with the 2 theta value 11, 22.9, and 34.8, which correspond to the reflection of D003, D006, and 012. In addition to these three main peaks, there are also two overlap peaks at this 2 theta. This overlap peak is characteristic for the structure of magnesium aluminum LDH. Based on the 2 theta value of the reflection D003, the basal spacing of this LDH is 8.65 angstrom. Medium acidity plays a very important role on the immobilization of this ascorbic, gallic, and salicylic acids, since the medium acidity will highly affect this chemical form and chemical form and the structure of this acid, as well as affect also the surface charge of the LDH. At the low pH value, the immobilization of this acid is very high and decrease continuously from pH 5 to the higher pH values. More detailed examination on the medium pH before and after the immobilization of the organic acid shown that if the immobilization of the acid is conducted at the low pH value, the immobilization of the acid give rise to the shift of pH value to the higher value. It means in this area there is a consumption of H+. On the other hand, if the immobilization of the acids is conducted in the high pH value, the immobilization is accompanied by the decrease of pH value. It means that the immobilization at this high pH value in this medium, there is a consumption of OH minus from the reaction medium. The immobilization don't change the pH, don't change the medium acidity if the immobilization is conducted at pH 5 for gallic acid and salicylic acid, and if conducted at pH 6.5 for salicylic acid. The presence of consumption of H+ when the acids are immobilized in the low medium and the low pH value, it must be interpreted as follows. The consumption of H+ in the immobilization of the acid at the low pH value must be caused by the consumption of H+ by the OH coordinated H metal ion of LDH according to this reaction. However, the consumption of OH minus when the immobilization of the acid is conducted in the high pH value
It is because of the consumption of OH minus, through the two possibilities. The first possibility is the anion exchange of OH minus with the interlayer nitrate anion according to this reaction. In here you can see that the interlayer nitrate anion will be replaced by OH minus. So now OH minus become the interlayer anion of the magnesium aluminum LDH. On the second possibility, that that may occurs to reaction of the OH minus with the release H plus from the LDH according to this reaction. At the low pH value, at the low pH value 5 or 6.5, the three acid, gallic, salicylic, and ascorbic acid, exist in the monodeprotonated form. Exists in the monodeprotonated species because their immobilization at low pH value is accompanied by the consumption of H plus. So their immobilization in the LDH should not proceed through the electrostatic mediated anionic exchange as shown in this reaction. Instead of this type of anion exchange, the immobilization of the acids must proceed through the formation of hydrogen bonding. For the ascorbic acid, the hydrogen bonding occurs through the deprotonated phenylic OH functional group of ascorbic acid with the protonated hydroxide functional group in the surface of LDH. In the case of gallic acid and salicylic acid, the immobilization was proceed through the formation of hydrogen bonding between the deprotonated carboxyl groups with the protonated hydroxyl group on the surface of LDH. The X-ray diffractogram, after the immobilization of the acid compared to the initial XR diffractogram of the magnesium aluminum hydrochloric acid, the immobilization gives rise to the broadening the main peaks of the LDH, especially to these two main peaks. Since there is and the broadening didn't accompanied by the shift of the position of the peaks. And then the important point that can be drawn from this fact is, since there is no noticeable increase in the interlayer spacing of LDH after the immobilization of the acids, it implies that the monodeprotonated form of this acid interacted dominantly on the layer and the outer layer of the layer structure of LDH. The possibility of monodeprotonated acid immobilized according to the simple electrostatic mediated anion exchange with interlamellar nitrate anion as interpreted in this reaction should be very limited. The immobilization of this acid on the magnesium aluminum LDH is non-linear. The absorption of the ascorbic acid, gallic acid, and salicylic acid can be seen here. That the absorption is very rapid initially at the initial state, and the absorption then goes lower and even reach equilibrium. Applying the two most commonly applied absorption isotherm model, namely Langmuir and Friendly isotherm model. All of this data, in fact, much better in Langmuir than Friendly isotherm models. So by applying this language isotherm model on this all data, then the result is given in this, is summarized in this table. As can be seen here, that the maximum ability of the magnesium aluminum LDH in absorbing these three different organic acids are relatively comparable each other. Although the capacity of the LDH in absorbing these three different acid species are comparable, but you can see here that the absorption energy for the ascorbic acid significantly higher compared to the two other acids. It is an indication that the deprotonated phenylic OH functional group of the ascorbic acid may interact stronger compared to the deprotonated carboxyl group of gallic and salicylic acid with the surface of LDH. Now we move to the application of the synthesized LDH and the synthesized organic acid immobilized LDH. First, the presence of gallic acid and also salicylic acid on the LDH enhance significantly the ability of this LDH in removing the gold-3 species. With the gallic acid, the performance of gallic acid better compared to the salicylic acid. As we know that gallic acid contains more phenolic OH group, more phenolic hydroxyl group than salicylic acid. So this functional group, this phenolic OH functional group must have positive role, positive contribution in removing the gold-3 species. Applying the three different kinetic model, namely pseudo first order, pseudo second order, and second order to this removal data, show that the data follows better to this pseudo second order compared to the two other kinetic model. And then by applying the pseudo second order, the obtained pseudo second order absorption rate constant is then presented in the next table. The pseudo second order absorption rate constant given in this column. And in the left hand column, it is the type of absorbent. You can see clearly here that the value of the pseudo second order absorption rate constant decreasing from the LDH itself to the ascorbic acid, salicylic acid, and gallic acid immobilize the LDH. You can interpret from this unit of the pseudo second order constant, because it is per mole per gram and per minute. So it reflects that the smaller the the smaller the value of the pseudo second order constant, the higher, the faster removal will occur. So based on this interpretation, we can conclude here that the absorption of gold-3 on the magnesium aluminum, which is immobilized by gallic acid here, is the fastest one. So the removal of gold-3 species on this absorbent gallic acid modified magnesium aluminum LDH is the fastest one, and then followed by respectively the salicylic acid, ascorbic acid, and then the bare LDH or the LDH itself. The absorption profile of the removal of good three species on these three different absorbent, at the three different temperature as the function of the remaining concentration of good three species at equilibrium, shown that the removal is very rapid in the low value of the concentration of the remaining acid, and the removal is then goes lower with the increasing of the equilibrium concentration of the acid, of the good species. Again, by applying the Langmuir and Friendly isotherm model, we have the result as presented in this table. Please concentrate on this column, the R square value on the plot of the removal good three species on the all absorbent and the all temperature investigated. It is clear from these two columns that the value of R square from the Langmuir model much better compared to the Friendly model. So it is an indication that all these absorbent have homogeneous surface with surface coverage is uniform for all active site regardless of the degree of coverage. This is the first point that we must obtain from this table. And the second important point you can see here, that the capacity of the all absorbent in this all temperature in removing the good three species decreases with increasing temperature. This is the numbers 2, the important point number 2 from this table. As previously mentioned, that the ability of the all absorbent in removing good three species decrease with increasing temperature. It indicates that the removal of good three species is an exothermic process. Then we use Van Hoff equation. This is Van Hoff equation, to prove this indication of exothermic process. From this equation, we can obtain the standard delta H and delta S, the standard enthalpy and entropy from the slope and intercept of the plot, this length K equilibrium versus these T parameters. After obtaining the standard delta H and delta S, then the standard free energy, Gibbs free energy or delta G can be calculated according to this equation. The employment of the Van Hoff equation gives result as presented in this table. First, the prediction of the removal of good three species on all absorbent is exothermic in nature is only confirmed for these two absorbent. You can see here that the standard delta H value are negative, so it means it is exothermic. On the other hand, the removal of good three species on LDH itself, it is endothermic, as shown by the value of delta H, which is positive. Then, unlike this delta H, the standard delta S consistently have positive value, indicating that this removal of good three species enhance the randomness of the system. Once more, with regardless of this standard delta H, the standard free energy for the all removal process at the all temperature, at the all absorbents are negative, indicating that the removal of good three species by all of this. Absorbance was spontaneous. The X-ray diffractograms after the good three species removal is presented here. You can see from the first part and the first diffractogram, the absorption of good three on the LDH give only peak broadening, especially on this 2 theta. It indicates that the removal of good three species by this magnesium aluminum LDH from the reaction solution was solely governed by absorption process. While if the removal is conducted by the organic acid immobilized magnesium aluminum LDH, the removal is accompanied by the presence of additional 3 new peaks as shown here. 1, 2, 3, or more clearly can be seen here. These 3 new peaks, it is related. They are related to the 111, 200, and 220 reflection on the face-centered cubic structure of gold, with the ability of gallic acid and salicylic acid in reducing the gold 3 species to gold metal bigger, higher compared to the ascorbic acid. This fact may be caused by the redox potential of gallic acid in this value and salicylic acid in these values are higher than the redox potential of ascorbic acid in this value. Now, based on the previous data, based on the previous explanation, based on this previous suggestion, known the mechanism of the reductive absorption of good 3 species on the organic acid immobilized LDH, magnesium aluminum LDH, is not interpreted here. First, the immobilization of all the organic acid proceed through the formation of hydrogen bonding. For the ascorbic acid, the hydrogen bonding, as mentioned before, it proceeds to the deprotonated phenylic OH functional group of the ascorbic acid with the protonated hydroxyl group on the surface of LDH. And this deprotonated phenylic OH functional group also responsible for the reduction of good 3 species to good nanoparticle. So this functional group is oxidized to keton. In the case of gallic acid and salicylic acid, the immobilization was proceed through the deprotonated carboxyl functional group with the protonated hydroxyl functional group on the surface of LDH. And the other functional group, that is the hydroxyl or the phenolic hydroxyl functional group for the GA, gallic acid and salicylic acid, are responsible for the reduction of good 3 species to good nanoparticle. The reductively adsorbed good 3 on the organic acid immobilized magnesium aluminum LDH may be recovered as nanoparticle by employing a proper extractant such as sodium dodecyl sulfate or sodium citrate. It is the example of the TEM image, the image of TEM from the good nanoparticle recovered from the ascorbic acid immobilized magnesium aluminum LDH by using sodium citrate solution. Lastly, as a conclusion, it is obvious that organic acid functionalized magnesium aluminum LDH is highly potential for the in situ synthesis of magnesium aluminum LDH supported gold nanoparticle. The conclusion number 2, the use of organic acids for reductive absorption process provide an easy handling and environmentally friendly way for the synthesis of magnesium aluminum LDH supported gold nanoparticle. The conclusion number 3, the reductive absorption of gold-3 species on organic acid functionalized magnesium aluminum LDH is exothermic and spontaneous. Number 4, gallic acid exhibited the highest absorption capacity and the highest in reducing gold-3 species. It is presumably due to the possession of more OH group, more phenolic OH group, and higher redox potential than ascorbic acid and salicylic acid. And the last conclusion, or conclusion number 5, gold nanoparticles may be recovered from reductively absorbed gold-3 species on organic acid immobilized magnesium aluminum LDH through extraction using a proper extractant solution. It is all of my presentation. Thank you for your attention. Thank you for listening. And I would like also to express my thankful to all my colleagues and to all my students whose their valuable contribution is unimediable. Thank you again, and good day.
Thank you, Prof. Sri Johari Santosa, for sharing with us such a very interesting topics. We are given until 9:40, so I would like to welcome any question from the audience. So participant, all the guests, okay, allowed to raise hands and ask question, and Prof. Sri Johari Santosa will inshallah answer the question for us, inshallah. So the time for question and answer session is only 10 minutes. Is there any question, please? One minute left. Okay. So, okay. So if I can summarize, the talk today is on the synthesis of organic acid functionalized LDH, and the use is on the reductive absorption of gold-3 to gold nanoparticle. I'm interested actually to know if from the idea it can also be used for other metals, right, Prof?
Yes, right, Professor Rohanan.
Yeah. So I think it's actually very interesting. Did you do any study on other metals? Is there any
Yes,
other?
actually, in addition to gold, we very intensively also studied the copper, Cu, copper, and AH, we call it in Indonesian or Malaysian perak,
Perak,
we
okay.
frequently use these two other metals, for what do they call, for synthesizing their nanoparticle form, because you know that if we get the nanoparticle form, so the performance of this type of metal will be increased significantly compared to the part, condition.
Okay, and in terms of the extraction of the metal, for example, in this, okay, I got the message from the host saying that there are 6 minutes left for question and answer. So it's okay, we have a question. But at the moment there is none from the audience, from the participants. So we are actually waiting for the participants to ask question. Meanwhile, I have another question, Prof. In terms of the extraction using this citric acid, right? Sodium citrate.
Sodium citrate, yeah.
Can you share with us? Can we get that 100% of extraction of gold from the sample?
Yeah, no, actually, if we try to extract the already reduced good nanoparticle on the surface of the LDH by the sodium citrate, the extraction efficiency is very hard to obtain 100. because in this type of extraction, there is a very strong competition between the sodium citrate from the extractant and the organic acid immobilized in the LDH. So I show in the last presentation, in the last slide, that it is just an example, but now it's still ongoing how to quantitatively extract from this good nanoparticle from this LDH surface, which is already immobilized by gallic acid, for example, in order to attract all of the good nanoparticle from the surface of LDH to the colloid form. You know that gallic acid, it is very strong. It is very strong in terms of the reduction potential. It's also very strong in the term of the capacity to absorb good trip species, because the reduction potential is relatively high compared to the general other organic compounds, and also the number of OH functional group on this gallic acid. It is every molecule gallic acid have three functional group, 3 OH phenolic functional group. While the other organic acid like salicylic acid, for example, just only have 1 functional group, OH functional. So this is if we use gallic acid immobilized on the LDH, it is very strong in reducing and also in absorbing this good species. But it is very unfortunate that how to extract from the gallic acid functionalized LDH. It is very hard to extract. So it is still ongoing, and we must do my best effort how to obtain quantitatively good nanoparticle from the surface of LDH.
Yes, it's interesting study. It's a challenge for everyone. So to take the challenge. So at the moment we don't have any other question. So in Malaysia, LDH is more, I think, based on my reading, some of the professors working on LDH is working on a slow release material. Such as fertilizer.
I actually also to apply the LDH to be an absorbent for humic acid from the pit soil, from gambut. Pit soil. So we know that in Indonesia and Malaysia, we have very large, very wide gambut area, pit soil area. So it is very interesting that we can apply this type of LDH to purify our soil water, our groundwater, in order to become the tap water that enable us to drink it directly, for example. It is very interesting also to apply this LDH to purify the pit water, pit soil water, or water that originated from pit soil area.
So in Malaysia, the water in gambut, tanah gambut, is very colored black.
Very colorful.
Okay, I think we have used up all the time given to us, Prof. So I'm very thankful for you for sharing with us your research. Thank you so much. I hope to see you in other occasion as well.
Okay, thank you. Welcome, Professor Rohana Adnan. Hopefully that we can still have opportunity to meet each other, maybe in Penang.
Inshallah. Actually, we have one more question. Can we allow one more question?
Please.
Yes, you can answer that one question.
Okay. This is from Budi. Okay. I would like to ask Professor Juari, may I know how the LDH selectivity for AU, gold, and other ions? It is. Is it
Thank you very much. Actually, that LDH is an ionic clay, anionic synthetic clay. So theoretically, it is unselective material. All of the negatively charged material will be absorbed, will be attracted by this type of anionic clay, anionic synthetic clay. So the main goal main goal of this research, actually, we try to recover gold from the electronic waste. You know that, in the electronic waste, of course, there are many type of metal inside. But after leaching with a strong acid, like aqua regia, for example, so all of the metal component in this electronic and electric waste, it is commonly the positively charged metal or cation, except for only several metal like gold, it is anionic one. So this anionic will be absorbed selectively by the LDH in the system, because copper, iron, lead, all of this metal will be positively charged. Only gold will be negatively charged. So this negatively charged gold will be selectively absorbed or interacted by the LDH, and because of the immobilized of the organic acid, the absorbed gold species that is negatively charged will be reduced, spontaneously by, like as shown before, gallic acid or salicylic acid or ascorbic acid, or maybe other acids. So after the reduction, you can find the gold nanoparticle on the surface of LDH. So after this reduction, we can, of course, apply directly this gold nanoparticle on the surface of this LDH as a catalyst, for example. But we still need extensive research for it, of course. Or alternatively, we can extract this gold nanoparticle from the surface of LDH by proper extraction, as mentioned in the last slide, by using the sodium citrate, for example. We can extract it, extract the gold nanoparticles. Maybe it is my response from the question of Mr. Budi, I think. Yes, right.
Thank you, Prof, for the answer, and also thank you to Budi for the question. So thank you so much. We hope to see you all in the next session, inshallah, and also in Penang, Prof.
Hopefully, inshallah.
Inshallah. Assalamualaikum, and a very good morning to everyone. Thank you.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Professor Dr. Sri Juari Sontasa M.Eng, for the great presentations, and thank you, Professor Dr. Rohana Adnan, for moderating these sessions. Ladies and gentlemen, there are a few sponsors which support this event. One of them is PT Spectacrum Indonesia, and this is the introductions video of PT Spectacrum Indonesia. Please enjoy.
Welcome everyone, and thanks for coming at this webinar. I'm Roberto Buschini, application specialist in Milestone for the extraction line and for the mercury line. During this quick presentation, I want to introduce you our line for microwave extraction. So a few words regarding the sample preparation. As you know, the sample prep is still one of the crucial parts of analytical process, and often the sample preparation is the bottleneck of your process. You have a huge number of samples, your analytical system can manage them. It's crucial to have a sample preparation that doesn't stop this chain, that doesn't break this chain. But of course, the sample preparation is also an investment, is also a cost for the lab. And so it's crucial to find the right sample preparation, the right balance between the quality of the results and the cost of the sample preparation. Here in Milestone, we have more than 30 years of experience in sample preparation for microwave digestion, microwave extraction, and microwave etching and synthesis. So over these 30 years, we have created several tools to help chemists, because helping chemists in sample preparation is still our goal worldwide. So a few words regarding this technique, and after that I show you some real application in which the microwave extraction strongly speed up your traditional approach for extraction. So how the microwave extraction works? Usually, I think that you have already experience with microwave radiation. How it works? Basically, the matrix, the matter, interact with the microwave radiation, that is a non-ionized radiation, using two main principles: the dipole rotation and the ionic conduction. But what's the most important point? Compared to a conventional heating in which you have an external tool that heats your sample, the microwave heating works directly on your sample. So the heat comes from your samples. It allows for a much faster and more efficient heating. Over the years, as I told you, we have created different hardware for microwave sample preparation. We propose the EthosX platform, as you can see in this slide, that is a very powerful oven in which using different rotors you can manage different applications, both digestion for elemental analysis or extraction. How it works? These rotors allow you to work with several samples simultaneously. And all these rotors work with closed vessel technology. So thanks to this technology, we strongly increase the temperature and the pressure of the system. What are the main advantages of this approach? For solvent extraction, if you can increase the temperature of the solvent above the boiling point of your matrix, of your solvent, it's clear that you can achieve several advantages. First of all, you have a better solubility of the analytes into your solvent. It means that the process is faster compared to, for example, a SOxLET extraction that works at the boiling point of your solvent. But increasing the temperature above the boiling point allows you also to have a lower viscosity of your solvent. It allows for a faster diffusion and a better penetration of the solvent into your matrix. We have created a line for extraction, as you can see, using one single platform, one EthosX, just replacing the tools and the rotors so you can manage different applications. We have application for the extraction of organic pollutants from environmental samples, for example, or even the extraction of fat from food and feed samples is another great market for us. Finally, we have also a nice patented solution for green extraction of fragrances, essential oil from botanics. Now I'll show you better in detail this application. First of all, the extraction of organic pollutants from soil, sediments, so environmental samples in general, using the Fastex 24 position rotor. What are the samples and the contaminants you can manage using this technique? Basically, we work with an official method, an EPA method. Into this method, you have a resume of the procedure. These are the samples you can manage using these techniques. As you can see, soil, clay, sediment, sludges, and also solid wastes. So a huge number of different solid and semi-solid samples for a wide range of compounds. Consider semi-volatile compounds, hydrocarbon, PAH, PCBs, pesticides, dioxins, and furans, and so on. Just with one configuration. A great important was given at the easy workflow when we developed this system, because we strongly believe that the sample preparation must be easy. because often the sample preparation is done by inexperienced analysts. So it's crucial to have an easy sample prep. And in this slide, you have an example of a FastTex workflow. This rotor works with disposable glass vial, and so it's very, very easy, like a sonication workflow. So you load the sample, you add the solvent, and you close the vessel and press start, using one of the building methods that we have already developed into our system, into our interface. So you don't need to create a new method. The disposable glass vials are the core of the system, because thanks to the disposable vial, you don't need a strong cleaning step of the system, like, for example, if you are working with pressurized fluid extraction, for example. But another important point, replacing the vial, you are sure that you don't have memory effect or crossover contamination of your sample. This vial has a large volume of 100 ml. It allows for a high sample amount. Just this way, it's easier to reach your detection limit. But also the solvent consumption is lower. Typically, we work with 25-30 ml of solvent per sample, for each sample. Typically, we work with acetone hexane, but in this rotor, into the FastTex ET rotor, you can manage any type of solvent. So if you want to change the solvent mixture, you can test different application. We have created several documents on this application for PAH, PCBs, dioxin, so feel free to ask us or our partner Spectra from these documents, and I can send you all these documentations that prove how the FastTex 24 works well on several certified reference material for all the compounds you have here. So just to resume the advantages of this system, FastTex 24 position rotor allows you to work with a great productivity. 24 samples simultaneously in 40 minutes, okay? It means almost 200 samples per day if you need such as productivity. The easy handling, I showed you, it's very, very important in this configuration. This rotor works with a contactless sensor, so you don't have internal probe or fiber optic or something, but just an IR sensor, contactless, that control all the 24 position you have, with a very, very low running cost. As I told you, we use 25 ml, 30 ml of solvent. And another important point, finally, the method is based on an official method, the 3546. So it's easier also to validate this method or to use this method in your routine workload. The other application I want to introduce you is the fat determination. For this application, the metrics of the sample are food and feed samples. You know how important is the total fat, the crude fat, and FAMES determination. With one configuration, we can manage both the applications. So total fat, gravimetric method that control the total fat content, crude fat, and the FAMES derivatization. Let me introduce you a bit the total fat. You know how important is this analysis worldwide, but usually the traditional approach involved several steps, an hydrolysis with boiling acid, so a long analysis. And so the time of this analysis is also 2 days for just one result. While with the microwave approach, we perform a simultaneous hydrolysis and extraction. So at the same time, you perform hydrolysis and extraction in the same vessel. It works for any type of food and feed samples with a great productivity, 15 samples in just 3 hours. 3 hours means from the sample prep to the results of up to 15 samples. The method is already accredited by several laboratories, several users worldwide with great results comparable to the traditional approach. In this slide, you have an idea also of the low cost per sample. The traditional method requires 100 ml of acid and 150 ml of solvent, while with the microwave approach, we use 10 ml and 25 ml of solvent. Again, it's a great way to save money also for the routine analysis, especially if you're working with several samples. So the method for total fat is applicable to any matrix. Consider 45 samples per day or 75 samples per day using 2 rotors. The core of the system, the main point is the simultaneous hydrolysis and extraction that allows you to work with, such as productivity. The cost per sample again is lower, and also the operator time is lower. It allows for a very fast return on investment. And finally, the essential oil extraction with the same configuration using the distillation modus. You can extract also essential oil, but for this specific application, for the extraction of essential oil from botanics in general, we have developed a specific line that, based on the quantity of material you have to treat, we have several, so 3 different configurations for university and RSD, for a medium-size processor, or even a big instrument for large-size processor. This line works without solvent. It's a patented technology by Milestone that allows you a very fast extraction with a quality of the oil that is better compared to the traditional approach. We work with fresh material, fresh frozen material or dry material without a problem, with a very easy handling. So today I don't have time to show you all these applications. We have also another application to show you, but if you are interested in this application, feel free to contact me. We can schedule a virtual demonstration. In this slide you have the contact of our partner, Spectrachrome, that is our best partner in your country, so feel free to contact them. They have a great experience in microwave sample preparation for both digestion and extraction. Again, if you want to run some real sample with me, you can send me sample free of charge. I'm glad to run your real sample, or I can show you directly with a virtual demonstration how the system works. So thank you again for your attention, and have a nice day.
Okay, ladies and gentlemen, we are continuing our program, which is to hear the invited speech that will be delivered by Associate Professor Jude Zahir from School of Chemical and Biomedical Engineering, Nanyang Technological University, Singapore. The invited speakers will be moderated by Dr. Bambang Purwono, MSc. Excellencies, presenters, and all participants, please welcome Dr. Bambang Purwono, MSc.
Okay, thank you very much for me. Before we start, let me introduce our speaker today. Okay, our speaker today is Zahir Jude. He's come from National University of Singapore. Maybe I will read up his background. Professor Jude has obtained a PhD in organic synthesis from University of New South Wales in 2000. And then after that, he joined with National University of Singapore for the postdoc. And then start from 2004, he joined a School of Chemical and Biomedical Engineering, Nanyang Technological University as an associate professor. His interest research is organic synthesis, medical chemistry, and drug natural formulation with over 20 years of experience. And also, Professor Yahir worked as a consultant for several companies, including MSD, Johnson & Johnson, ExxonMobil, or Resources. And his work mostly in synthesis of drug intermediate, analysis of the product and byproduct. Also develop a formulation and providing expert opinion on material and analysis. So far, the Professor Yuda is got a high index in Scopus 21, and today he will present for us is with the title of Cascade Synthesis of Furan Carbohydrate. Maybe before we start, the time for presentation is 20 minutes, and then 10 minutes for question and answer. So for the participant who will ask to Professor Yuda, please raise hand from this Zoom application. Now it's time for you, Professor Yuda. Okay, thank you very much.
Assalamualaikum. Can you hear me well?
Yes.
All right. Good morning, everybody. I would like to thank the organizing committee, Professor Roto, and my good friends, Professor Bambang and Tutik, whom I know for the past 25 years, since we were students at the University of New South Wales back in Australia. Today, I'm going to share with you a very small topic about our activity in carbohydrates. I would like to continue the theme that Professor Santosa have started on a green synthesis, and therefore I will talk about carbohydrates. We all know that carbohydrates can be used as sustainable materials for synthesis. You can see here in this slide is a platform of different materials that we can use to obtain from carbohydrates. Specifically, we're talking about C5 and C6 sugars, pentoses and hexoses. Basically, there are 4 platforms. You can see the glycerol platform, the sorbitol platform, levulinic acid platform, and the butyrylactone platform. These platforms give you various compounds, these compounds are obtained in processes that industries would like to use in their manufacturing. Along this theme, we wanted to understand how can we make specific kind of compounds. If you notice from this slide that most of these compounds are open chain, and small fraction of these compounds are cyclic compounds like what you see here, here, and here. The objective of the research we started 4 years ago is how can we convert carbohydrates to heterocyclic compounds. If we look at the basic structure of carbohydrates, we have aldoses, what you see here, and we have ketoses. These aldoses, if we look at the tautomeric structure, they contain an aldehyde group. Ketoses, they contain a keto group. So this kind of masked aldehyde and ketones can be converted to cyclic structures. They are very good sites for reactivities. Our research in the past 4 years is summarized in this slide. What we do is we take carbohydrates, we react the carbohydrates with active methylene compounds, what you see here, right? And this is our active methylene, all right? And then we obtain these heterocyclic structures. Today, I'm going to talk about tetrahydrofuranes, all right? This kind of work that I'm going to talk to you about today has been published in Green Chemistry. We have published another research on obtaining pherols from carbohydrates. This work has been published in GOC recently. These two works, we have 2 manuscripts ready for submission. So we're going to focus on how do we obtain furanes from carbohydrates. Well, why we are interested in the furanes? These kind of heterocyclics are obtained from various plants and microorganisms. They are well represented in different pharmaceuticals, fine chemical, agrochemicals. And I'm showing you here in this slide one of the blockbuster drugs. Many of us use this drug if we have ulcers in our stomach, and this drug is called Zantac. It has this furan ring. Likewise, when we get old, we tend to have body retained, water retained in our body, and we use furosemide to get rid of water from our body. This again contains tetrahydrofuran ring. Likewise, we have these antibiotics for antibacterial compounds which contain this furan ring. The particular structure that we are interested in is something called polyhydroxy alkyl furan. This kind of structure, this framework is very, very interesting because it is containing different characteristics that are used to obtain potential drugs. For example, it has a hydrophilic section. This is our hydrophilic section. It is a lipophilic section also. This ring here, the aromatic ring. This aromatic ring is rigid. This side here is flexible. Of course, this is chiral, and we have an interesting electrophilic center here that we can use to convert to various structures. For example, we can oxidize this keto group. We can get carboxylic acid here with this side chain. We can even remove the side chain and obtain this carboxylic acid. We can do a reduction of this keto group to obtain the alcohol. We can cyclize this ring here and here. We can dimerize the structure to obtain dimers. We can convert this polyhydroxyalkyl chain to an aldehyde, just one-step reaction, and we can change this group to another heterocyclic or another heteroatoms. So this is a very impressive framework that we can utilize. The question is, how do we get this framework from carbohydrate? Well, this type of framework has already been obtained 70 years ago, not very recent. It's a long history. This reaction has been very well reported and very well optimized by Gonzalez, and it takes after his name. He took different kind of carbohydrates and 1,3-diketo compounds. In the presence of a Lewis acid, he was able to obtain these polyhydroxyalkyl furans. If we use bases as a catalyst, we don't get the furans, we get something called C-glycosides. When we started this reaction, our aim was to obtain the glycosides. That was our aim. But then we got interested in this type of compounds because we have another platform of research which deals with medicinal chemistry. The type of R group and X that Gonzalez has reported are mentioned here. Basically, our R group is an alkyl group or an aromatic ring. The X here is an ester or an ether. Then we ask ourselves two questions. The first question we ask ourselves is actually three. So the first one we ask ourselves, how come there's only a keto group here? Can we change this keto group to another functional group? All right, for example, a lot of drugs or intermediates contain nitrogen. How can we change this to a nitrogen? Or how can we change R to a nitrogen? That was the first question. The second question we ask ourselves, the substitution here is 2, 3, 5. Can we obtain 2, 3, 4, for example? The third question we ask ourselves is, how about this? Can we change this to nitrogen to obtain pyrroles? So these are the questions that we asked ourselves. So initially, when we searched in the literature, we found that there was a reaction that has been obtained in 1989. And this paper was very, very interesting. It is just a single page publication that contained a single example, that contained just one catalyst, and we only got 20% yield. So we got interested in the work that was reported, and we wanted to understand, why did these guys only publish one example of sugar and only used one catalyst? And why was the yield so low? And in the case of Garcia-Gonzalez reaction, the yields are almost quantitative. So this was a little bit puzzling for us. And I wanted you to understand that we were interested in these heteroatoms to have here instead of the oxygen. So we wanted to address these questions. So what we did, we took this reaction here, we took the same reaction here, and we wanted to play with the condition of the reaction. So we took ribose, and we took malonitrile, and then when we did this reaction using the Lewis acids that Gonzalez has used, the yield was basically zero, nothing. We couldn't obtain anything. However, when you use different bases, we got almost quantitative yield of this structure we were after. We were very happy to get this. So DBU, and during this initial work and screening, we got 7A, what we wanted, and then we got something interesting. These are the structures that we also obtained. Initially, our NMR were complex because they were mixtures of products. DBU gave us 100% of our furane, likewise triethylamine, likewise trimethylamine. Pyridine gave us nothing because of its low basicity. Sodium methoxide gave us also 100% of our furane. When we use sodium bicarbonate, and when we use a lower amount of DBU, we were started to obtain mixtures of 7A as well as 7B, which are these two structures. All right. After a lot of screening, we came to a conclusion that the best conditions for this reaction is using a triethylamine, 0.15 equivalent. Within 4 hours, we were able to obtain an excellent yield of 7A 100%. I wanted to draw your attention to these conditions here. First, we're doing our reactions in water. So it's a complete kind of water solvent. And if you look at the E factor, it is less than 1. And this is very critical because whatever you use, everything you use here and here, everything you use, it's converted to the product. What we lose from here, it's only water. So it's basically a dehydration reaction. All of this, what you have from here to here, is just a simple dehydration reaction, as I'm going to explain to you. So the atomic economy of this reaction is really, really good. And many of us, when we talk about carbohydrate, we know that carbohydrate is a complex chemistry and reactions are usually very messy. But then when we did this reaction, we were really surprised that after you mix your ribose with the nitrile in an NMR tube, you get this spectrum pure, no purification needed, nothing. This is as pure as you can get. You can even see the satellite, the carbon satellite, indicating this is really a pure material. We were very happy. So no purification was required here. In this case here, I'm showing you the reaction with trimethylamine. But earlier, I told you that we are using triethylamine. The reason is that this is a gas and it's always used in solvents. We couldn't really get it to our lab. Okay, so after establishing the conditions here, optimum condition, we wanted to understand if other carbohydrates can be used for this reaction. What I told you earlier is that this paper only used only one carbohydrate. So we did a number of reactions, and we found that pentoses and hexoses both react almost quantitatively to give us 90 to 98% yield. Ribose, arabinose, xylose, glucose, mannose, galactose, rhamnose. All of these react to give us the products that we are after. That was really good. We also extended the reaction not only to monosaccharides, but to disaccharides with the malonitrile, and we used maltose, lactose, and syllabiose. You can also see that these yields are high, very high yield. I should say that this reaction here, although it's very pure, but the issue that we faced with this reaction is the following. When we wanted to do, when we wanted to remove triethylamine, it was very difficult to remove. Triethylamine was trapped in the product. We thought that we could just, simply evaporate the product, and then triethylamine will just be evaporated. But however, when we did this, we could not get rid of a triethylamine even if you keep it under vacuum for a few hours. So we couldn't do that. The only way we could get rid of a triethylamine if we flush our column, if we flush our product through a silica column. All right. And for that, we discovered that these type of compounds are very highly polar compounds. The reason is because they contain a lot of OH groups. So the polarity is really high. So we had to use methanol to flush this. The reason why triethylamine is stuck, I think, is because of hydrogen bonding that triethylamine makes with these OH groups. So it's really very tightly stuck. All right. So this type of reaction was very successful with malonitrile. And then what we wanted to do is to understand if this reaction is a little bit more general. Therefore, we used this malonamide. We were also very happy to find out that pentoses and hexoses react with the malonamide to give us very high yield of these products. Again, we used ribose, arabinose, xylose, glucose, mannose, galactose, and rhamnose. And all of these starting materials, all of these sugars, gave us very high yields. Likewise, we used disaccharides with the malonamide, and again, we got very high yield of these compounds. Again, these compounds, because they even contain more hydrogen bonding, they were even more polar. Same, the only way we can get rid of a triethylamine is through the process of passing it through a column chromatography. We also wanted to understand if this reaction is even more general. So what we did, we took cyanoacetate and we did the following. We took the pentoses and hexoses, react with the cyanoacetate in the presence of these amines. What we wanted to do is that these amines will react here, and the product we get is a three-component reaction. We were very happy to get this reaction going. The yields are a little bit lower, but generally they're over the 70% mark. So we use again ribose, xylose, again from ribose here with different amine, here and here, glucose, galactose, and again from glucose. This work is still in progress, but what we wanted to demonstrate is the importance of adding a functional group here. In this case here, this will be our amide. If you look at the previous cases here, we have a free amide here, and here we have a nitrile. This nitrile can be converted through a reduction to amine. It can be hydrolyzed to a carboxylic acid. So it has a lot of use and ability to be converted to different functional groups. All right. we wanted to understand if this reaction can be scaled up easily. So what we did this reaction in a 2-gram scale. All right, and the reaction we were very happy to find out this reaction can proceed at 2-gram scale without any compromise in the yield. So we did the reaction with malenomide. It gave us this, and this one can easily be converted to aldehyde. It's a simple treatment with sodium periodate to convert it to the very, very important industrial structure called furfural. But it's not just furfural, it is functionalized furfural. So this reaction was done stepwise. We can also do the reaction as follows. This furfural here can be reduced. The aldehyde here can be reduced to the alcohol using sodium borohydride. What we wanted to understand is, can we do this reaction in one pot? So we combine step 1, step 2, and step 3 in one pot and obtain this. So we have done this, and we were able to obtain this alcohol in 89% yield over 3 steps. The large-scale reaction was done with malonitrile. It was also successful with malenomide with 84% yield. So we concluded that this reaction can be done on a larger scale. Not only monosaccharides can be done on larger scale, disaccharides were also done in large scale. So we could obtain these disaccharides, furanes, in large scale as well. Another work we did is, because we have used different kind of bases and we obtain these kinds of intermediates, we wanted to understand what really happens during the reaction and what is going on. This is a study that was done to help us understand the mechanism of the reaction. So what we did here, we did the reaction in the NMR tube using D2O, and we took the NMR of the tube at 0 minute, 20 minutes, again 40, all the way till 3 hours. We know that the reaction is finished at 4 hours. I want you to only follow 2 things. This signal here, H1, and these 2 signals here. This signal is marked here. These 2 signals are marked together here. In the beginning, when reaction is just only after mixing everything together, there is no products here. After 20 minutes, we start to get this product here. And the majority of the product is actually these intermediates. As time proceeds, we can see that these intermediate signals decrease while this signal here increases. So this kind of told us that these 2 are actually intermediates and they are converted to the product here. That's what this study told us. And from this study, we came to understand and suggest a mechanism for this reaction. So the mechanism that we proposed is as follows. This is shown with ribose. Tenomerization give us this aldehyde. In the presence of a triethylamine, we can pick up one of these acidic protons. They are very acidic, and you generate a nucleophile that reacts here. And this is our first intermediate. What happens to this intermediate in the presence of base? We get this acidic proton and OH here. We lose water, and we get this intermediate. Now, this is the fun thing that starts here. This intermediate is very reactive, and we have 3 ways by which this intermediate reacts. If you follow this arrow, the red one, you will get this red intermediate. So this nucleophile react on this carbon here, kick out electrons, this kick out electrons here, and you get this intermediate here. If you follow this arrow, the black one here, again, it reacts on the same carbon, oxomical reaction, kick out the electrons and electrons here, and you get this intermediate. This is a 5-6, this is a 5-5 intermediate. All right. What is good about these two intermediates here, if we take out this proton here, the base takes us to the proton, electrons go here, this opens up, you get this. Likewise, if we take this proton here, the acidic proton here, electrons go here, the ring opens up, and we get the same exact product. Now, there is another mechanism by which we can obtain this product, which is something called the Thorpe-Ziegler reaction. The Thorpe-Ziegler reaction is followed by the pink arrow here. This oxygen react here, kick out electrons, and we get this intermediate here. Now, this intermediate here, it undergoes aromatization to stabilize the structure. The base take out the proton, electrons move here, kick out electrons, and they finally go on the nitrogen to give us this intermediate, this final product. So we were happy to get this final product along these intermediates. All right. In our case, when we obtain these intermediates, we thought, okay, we can just keep them on hold and we will look at their synthesis later. But then I just reviewed like 2 months ago, I just reviewed a paper that deals with the synthesis of these intermediates. And they refer to our work as an extension. So our work now is stopped at this because it's already been published by somebody else. All right. So in summary, what I have shown you, a very practical, probably industrial feasible scale reaction. So one pot is catalyzed by triethylamine to give us a very good yield of functionalized furans. And I have also shown you a simple mechanism that involved novel gene condensation followed by oxomical addition and Thorpe-Ziegler reaction to give us our product. This reaction is considered as a green with an E factor that is less than 1, which is really, really good. And it can be obtained at 2-gram scale. Finally, I would like to thank the person who did this work, which is Malik. He's a very good carbohydrate chemist, and Mingsen helped him to do some of the work. Mingsen is a PhD student. She has done the work on pyrroles, which was just published in JOC. Of course, I would like to thank the Nanyang Technological University for financial support, and I would like also to thank you all for listening to me and giving me your time. Thank you so much. I'll be glad to answer any question. Bye-bye.
Okay, thank you, Professor Yahir. But unfortunately, we have maybe one question, if any, because in short, because the time is very limited.
Yes, please.
Is there any question?
Yes. Could I ask some questions, Prof. Zahir? Hello, how are you?
I am good, thank you.
Thanks a lot, Prof. Zahir, for joining to this conference. And my question is just a short. In page 16, you show that you can make in one pot reaction, right? 16 something. 16, yes, this one. Have you ever tried to synthesize the furfural in one step, only in one step, or you combine 3 of this step together?
Have I tried to?
Into the furfural itself in one pot reaction.
Yes. So this is the one pot reaction. We were able to make this to convert this one in one step. Yes.
Okay. It works really.
It works. It works. So if you can do it in 3 steps, 2 steps should really work.
Okay. Yeah, possibly I can ask you about the journals that where you published this result, right? Have you published this?
So this work has been published in, as I stated in the beginning.
Okay. Yes.
So yes. Sorry. So this work has been published in the Green Chemistry Journal.
Green Chemistry. Okay. Thanks a lot, Rangsil.
Thank you so much. Thank you.
Okay, because of time is very limited. Once again, thank you, Professor Jahir, for the presentation. And then now I keep a time to the next agenda. Thank you very much, Professor Jahir.
Thank you.
Okay, welcome.
Thank you, Professor Judeh Zahir, for the great presentations, and thank you, Dr. Babang Purwono, MSc, as the moderator. Ladies and gentlemen, those are the agendas we have presented to you this morning. We have finished our opening ceremony. Coming up to the next session, we are going to have a parallel session. After the end of the parallel session, we are going to have lunch and prayer break. And the second keynote speech will start at 1 p.m. Western Indonesia time. So please go back to the main room 5 minutes before that. For those who joined the parallel session, please be noted that our session will start momentarily. Now you can proceed to your presentation room. Thank you. announcement for the non-presenters who are registered are allowed to choose which breakout room to join during parallel sessions. So please enter your preference room. Thank you.
Assalamualaikum warahmatullahi wabarakatuh.
Manis. Ah.
Oke. Iya Mas, suara itu masuk nggak Mas? Bentar.
Udah bagus Bu.
Masuk ya?
Iya.
Assalamualaikum warahmatullahi wabarakatuh. Masuk ya?
Iya Bu.
Ya, oke.
Sudah oke.
Ya.
Good afternoon, ladies and gentlemen. Welcome back to the meetings. Now we are going to the next agenda. That is the second keynote speech from Associate Professor Oh Chuan Wei from School of Chemical Sciences, University Science Malaysia. The second keynote speakers will be moderated by Dr. Tuti Dewiwayuningsih, MSc. Now, please welcome Dr. Tuti Dewiwayuningsih, MSc. The time is yours.
Okay, thanks a lot, Fadli, for the time. Good afternoon, everyone. Assalamualaikum warahmatullahi wabarakatuh. Distinguished guests, all of the keynote and invited speakers, especially Dr. Oh Chuan Wei, our respected colleagues from UTM and also from USM, and all of the ICCS 2021 participants. This afternoon session, we will have a keynote speakers from USM, University of Science of Malaysia, Dr. Oh Chuan Wei. Hello, Dr. Oh. How are you? It's still unmute. Yeah. Okay. How are you, Dr. Oh?
Yeah, I'm good, Prof. Tuti. Thank you.
Okay, thanks a lot for joining to this conference. Okay.
Thanks for the invitation.
Yeah, you're welcome. Okay, ladies and gentlemen, before we go through this session, let me giving a brief curriculum vitae of the Associate Professor Dr. Oh Chuan Wei. So, Dr. Oh is graduated from University of Science of Malaysia, getting a PhD in 2008. And then right now, he is become a, wait a minute, I have to, become Deputy Dean for Research, Innovation and Industry Community Engagement at the School of Chemical Sciences, USM, since January 2019 till this year, I think, December 2021, right? Okay, and next, a lot of publications has been done by Dr. Oh, more than 60 articles were published in the peer-reviewed Scopus IC Index journals. And for the conference and workshops, he became an invited speaker for the International Symposium on Chemistry and Material Sciences in 2018 at Soka University, Japan. And in 2017, he became invited speakers at the 6th International Conference for Young Chemists at USM, Malaysia. He got a lot of funding research. And next, please, this is, oh, wait a minute. Move back, please. Okay. In this contextual research grants is really, you know, we know that twice research grants is really popular, and I think you've got a good research in this case in 2013 and 2014. And then next, a lot of funding from Ministry of Higher Education Malaysia and also from the university, from USM. And since 2019, Dr. Oh is doing the research about synthesis, characterization, and mechanistic studies of stilbenoid derivatives as potential vasodilators. And today, I think he will present about these stilbenoid topics. So please welcome Dr. Oh to do the presentation. I think it's about 30 minutes presentations and 10 minutes about discussion, right? Yeah.
Okay.
And for everyone, for the participants, you can write the questions in the column chats, so it make us easy to follow the question. Okay, so please.
Okay. Thanks, Prof. Tuti. Allow me to share my slide of presentation.
Please.
Can you see the slide?
Not yet. Okay, and then slideshow, please.
Yes.
Yes, thank you.
Okay, thank you. Okay. Okay. Very good afternoon to everyone. First of all, I would like to thank the organizing committee for the 4th ICCS 2021 for giving me this opportunity to share my little bit of my research work on the new stabilinoid-based antihypertensive agent development, discovery of the new lead compound. I am Wu from School of Chemical Sciences, University Science, Malaysia. I'm pretty sure that this term, hypertension, is no longer a strange term to most of us, yeah, and it is actually a condition that being diagnosed in a person when the systolic blood pressure is more than 130 millimeter of mercury, and the diastolic blood pressure is more than 80 millimeter of mercury. Some of us may think that this particular measurement is considered as a normal reading now, okay? And of course, if you look into the guidelines of hypertension by American Heart Association, especially those published by the Harvard Health Publishing in this year, 2021, okay? If you are having this reading over here, you are said to be diagnosed with the stage 1 high blood pressure. Some people say, okay, you have to start to taking good care of your diet. But if your systolic reading is 140 and above, then you have to start to really take note on it. However, if you get a higher reading that will be like more than 180, then you will be suffering from a condition known as a hypertensive crisis. This is a time that you really need to consult your doctor immediately. If you look into the world statistic in year 2021, it reported that there are around 1.3 billion adults aged between 30 to 79 is suffering from this hypertension disease. And if you look into the data for Malaysia itself, all right, 2 out of 3 adults are actually suffering from this illness, and it averagely affecting around 11 million of adults aged 18 years old and above. Not many patients of hypertension really seek for the medical attention, okay, but those who really seek for this medical attention, only 1/3 are able to control their blood pressure. And now that we can foresee hypertension is actually a future incurable disease, and it's quite a burden, all right, to most of the adults in Malaysia, okay, in Malaysia, and it could be a major cause of premature death worldwide as well. So by having this problem, okay, a person may experience the following signs and symptoms like vomiting, dizziness, and of course, you may feel tired quite fast and quite often as well. If a patient do not have the blood pressure under control or under medication, the situation may become worse and it may trigger more serious issues related to cardiovascular diseases, okay, like stroke, or you may have the acute heart failure, heart attack, and not only those related to the heart, okay, and you may develop kidney failure as well. So by knowing the seriousness of hypertension, okay, and there are so many drugs being developed, okay, because this is not really a new disease, all right, so there are a lot of drugs already developed in the market, okay, and research are still on, actually, research are still on in order to looking for a better medication, better drugs, okay, to control the blood pressure of the patient. And one of the drugs that usually often used is known as the vasorelaxants. So vasorelaxant is actually a term that given to a chemical compounds that react with the muscles of the blood vessel, okay. What happens is it will stimulate a rapid widening effect on the blood vessels, okay, that allows the blood to flow much more smoothly. Currently, there are 2 drugs, okay, that commercially available in the market. Of course, there are more, but I'm showing here is only two, hydrazine and minoxidil. Okay, these two drugs will increase the capacitance of the blood vessel and it reduces the obstruction effects of the blood vessel. Again, it will allow the blood to flow much smoothly in the blood vessels. So by looking into the property of these vessel relaxations that were able to dilate the blood vessel, and that, of course, in that case, it will bring down the blood pressure of the hypertensive patient. So we started to develop or to design or to synthesize these vessel relaxants. I think back in year 2000, much earlier, back in year 2015. Okay, we start with the chalcones. Okay, before we work with the stilbene derivative, or more specific, the stilbenoids, we try to synthesize the chalcones, which is a flavonoid compound. Okay, having the two aromatic benzene ring joined together via this alpha beta unsaturated carbonyl system. So why we start with the chalcone is all based on previous literature review showing that certain chalcones, okay, they're showing the anti-inflammatory properties that possibly make them a good candidate to treat these cardiovascular related disease like hypertension. So in our study, we synthesized the indanone-based chalcones, okay, by reacting the one indanone with the substituted benzaldehydes, okay, under basic condition, then we produce the indanone-based chalcone. We work on a few, right, products, but here I'm really showing the 6 products over here. The issue with this chalcone is their solubility in water, which is one of the requirements for the chalcone, for the drugs to undergo this vessel relaxation, what's called study. Okay, and out of these 6 chalcones, okay, unfortunately only 2 are able to soluble in the water. Okay, but not by themselves. Okay, their solubility still need the assistance from the twin 80, okay, which is surfactants, okay, to help them dissolve in water. And the rest, like 1B2, 1B3, those with the R group as a nitro and the chlorines, these 4 were found not soluble in water, so they do not undergo this vessel dilation investigation. For the 2 indanone-based chalcone that show a solubility in water, okay, both of them giving the Rmax value. The Rmax value is actually the maximum value of relaxation, okay, from the vessel dilation study. So it shows that when the R group is the etoxy groups, the Rmax value is around 39%, and when the R group is the Husserl group, the Rmax value is quite high, 96%. Actually, this 96% is much higher compared to the positive control that we are referring to. But we did not continue with the indanone-based chalcone that we designed previously due to their poor solubility in water. Okay, so because of this, it led us to look into other better candidates, okay, that would be able to dissolve in water much better. So that is the time when we focus into the stilbenoid or the stilbene derivatives. So what makes us really pay attention on these stilbenoids or stilbene derivatives is due to this resveratrol. It's actually a 3,4,5 trihydroxy stilbenes having the trans isomerism, okay? And this particular compound is a natural compound actually, and it's been first isolated back in many years ago, 1939. So it's not a really new natural compound. But there is one statement known as the French paradox, okay, that is really related to this particular natural compound, resveratrol. So some of us may have heard about the French paradox. It is the statement saying that there is a quite low incidence of mortality rate due to the heart disease in France. Okay, even though they are saying that the French diets are high in saturated fats. Okay, and in fact their blood cholesterol and blood pressures are also not lower compared to us. Okay, but it seems that they don't have much fatality, all right, rate that arise from the heart disease in France. Okay, and it is so that it could be due to their daily dietary source, okay, which contains a high amounts of resveratrol. Okay, so these paradox, some people conclude a very gross conclusion saying that resveratrol could be the compounds that could prevent the coronary diseases. And until now, we can find that resveratrol is being sold as a supplement, okay, as a supplement. So based on these French paradox, it really catch our attention that we want to try to work on these resveratrol related structure, okay, that will be the stilbenes. So this is a basic structure of stilbenes. Okay, it is actually a compound having the C6, C2, and C6 backbones, in which you can see that there are two aromatic benzene ring that join together through this vineric system, and these double bonds here, okay, make the stilbene can present in either the cis or the trans configurations. Of course, the trans configuration will be the much stable over here, and the stilbene derivative could have a different substituents, okay, different type of substituents, and with different numbers and at different positions on the A or on the B ring. Okay, so previous studies show that there are so many bioactive stilbenes, okay, as shown in this slide, and of course, resveratrol is one of them. Okay, and if you look into the studied properties of these stilbene derivative, these four examples, they have shown potential vessel relaxation in widening the blood vessels, okay, on the study subject. Okay, like this pisiatanol and resveratrol, okay, it has shown effective in activating and regulating the endothelial nitrogen oxide synthase, which is one of the vessel relaxation pathway, all right, in the rats. And again, resveratrol and ginetol also have been showing to enhance the diastolic functions, okay, in spontaneous hypertensive rats as well. And resveratrol itself, there are a lot of clinical study showing that resveratrol can actually improve the ventricular diastolic, okay, and the endothelial function of a patient which is having the coronary artery diseases in just 3 months. Okay, so the resveratrol over here is our reference compound, all right, that really encourage our research group to work into this particular project. So if you look into the structure of resveratrol, okay, there are few words being worked to produce different type of stilbene derivative, okay, and they are, however, all these synthesized stilbene derivative being used and focused on their anti-cancer and antioxidant properties. Not much study have been done to study their anti-hypertensive property. Okay, so this raises our research questions. Could there be any stilbene derivative that would act as a better anti-hypertensive drugs compared to this resveratrol? Okay, and if there is, what could be the requirement in their structure, all right, so that they could show a good or even a better vessel relaxation effect? Okay, so other than OH, could there be any better substituents? Okay, and would the position of the substituents and the number of substituents on the A and the B ring of the stilbenes can improve, okay, can improve the vasodilation effects of the synthesized drug. Okay, so based on these research questions in our this small project, okay, we look into the synthesis of the alkoxylated steel beans derivatives, and we have the alkoxy groups over here. This is the first stage. We work on the ethoxy group and the methoxy groups. Okay, and we have different numbers of these alkoxy groups that attach to the different positions of the A and B rings of the steel beans. And after that, we try to convert the alkoxylated steel beans into the hydroxylated steel beans. That means that all the alkoxy groups of these alkoxylated steel beans will be converted or were converted to become the hydroxyl groups. And with these two classes of compounds that being synthesized, the alkoxylated and the hydroxylated steel beans, we did some vasodilation study to test, to investigate their in vitro vascular response. Okay. So, and from this scope of study, I would like to share here, we managed to synthesize, at the moment, at the stage, we managed to synthesize roughly around 25 compounds, okay? 25 compounds, and they can be categorized into 4 groups, okay? The first one is the tri-ethoxy steel bean derivative, in which we have the 3 ethoxy groups, okay, attached at the different positions of the B ring, okay, as well as on the A ring, sorry, as well as on the B ring over here. And we have the tetramethoxy also. We have a 4 methoxy group attached to the A ring and the B ring, respectively, A ring and B ring of the steel beans. And we have synthesized 2 dimethoxy steel bean derivative. And of course, the last one, we convert some of these alkoxylated steel beans to become the hydroxylated steel beans. I would like to mention here, our initial aim is to convert all of the alkoxylated steel bean derivatives to become the hydroxylated steel bean derivatives. But however, in the end, we found that not all of these alkoxylated steel beans can be converted to become their hydroxylated derivative, and we only managed to get 9 what's so-called hydroxylated steel bean derivative. Okay, the synthesis of these steel bean derivatives starts from the preparations of the phosphonium salt. And when you see it's a phosphonium salt, definitely we know that the process is a Wittig reaction. Okay, and first it starts with the dihydroxybenzoic acid. Okay, in this case, the R2 to R6 is at the moment is the hydroxyl groups, and the first step is involve the conversions of the carboxylic acids to become the ester group via the Fischer esterification, and then what happened next is like we try to convert some of the hydroxyl groups on R2 to R6, we convert some or all, okay, to the ether group by Williamson esterifications, okay. And next, this ester group is being reduced under the hydride reduction reaction by using the sodium borohydride to become the primary alcohol that eventually converted to become the alkyl halides by using the thionyl chloride over here. All right, and lastly, the benzyl chloride, okay, was converted to become the phosphonium salt, phosphonium ions, okay, by using a triphenyl phosphazine. Okay, yes. So once this salt is prepared, okay, then it's ready to react with the substituted benzaldehydes, okay. Through these Wittig reactions, then we get trioxy, the tetramethoxy, as well as the dimethoxy steel bean derivative. So this particular Wittig reaction is well reported, okay, and it's quite straightforward as well, okay, to prepare all these steel bean derivative. Okay, so after that, at times we try to convert the alkoxylated steel bean derivative to become the hydroxylated steel bean derivative. As I mentioned, our initial aim is to convert all the alkoxylated steel bean derivative to become the hydroxylated derivative. But however, in the end of the attempts, we found that not all of them are able to be converted. Okay, we only managed to convert 9. Okay, and to 9. Yes. We use the aluminum trichloride, what's it called, aluminum trichloride dimethyl aniline system. Okay, in this conversion is actually a polyoxy dealkylation process in which that all these alkoxy groups, okay, were eventually converted to become the hydroxy group. Okay, and if you look into the literature, okay, people also been trying to carry out this dealkylation process by using what's so-called the boron trihalides. Okay, the most used is with the BBr3, boron tribromide. Okay, and in our another work, okay, we did some conversions working on the flavonoid, okay, working on flavonoid to convert some of the alkoxy group of the flavonoid to become the hydroxy group. But with BBr3, okay, the conversion of the alkoxy to the hydroxy group is quite selective, okay, and not all of the alkoxy group will be converted to become the hydroxy group. And our initial work is we did plan to use the BBr3, okay, in the conversion of these alkoxylated steel beans to become the hydroxylated steel beans, okay. But eventually, we found that we no longer able to purchase the boron tribromide, okay. Yeah, and it's not available in Malaysia anymore. So that's why we've went through certain period of headache, okay, to looking for the better converting reagents. Okay, we tried BCl3, boron trichloride, okay, but the results were not good. All right, most of the conversions seems to be failed. Okay, and in the end, we managed to look into with some literature that using the aluminum dimethyl aniline system. Okay, so if you look into this slide, the process of the alkylation using this aluminum trichloride, this one, aluminum trichloride dimethyl aniline system, is actually not well or not fully known. Okay, so we did propose this dealkylation mechanism in which that there is a possibility. At first, we have the nucleophilic alkoxy oxygens will attack the electropositive aluminum atom from the aluminum trichlorides, okay, and it will flow by the dealkylation. At this second stage, we have this dimethyl anilines as a base to extract which we call the alkyl groups from this complex, okay, amine complex, and then it will flow by the protonations on the negatively charged oxygen, positive charged oxygen atom, okay, and we presume that this particular reaction is driven from the breaking of the aluminum oxygen bonds, okay, that will regenerate the aluminum trichloride, all right, that will be used in the subsequent reactions, okay. So this is just a proposed dealkylation mechanisms by using the aluminum trichloride and dimethyl aniline system. And as commonly, we characterize the synthesized steel bean derivative for their physical and chemical properties. Okay, we did on here show the melting points of the synthesized compound. Okay, most of the alkoxylated steel bean derivative was showing the melting points from around 70 to roughly 150 degrees Celsius. All right, and as you can see here, when the linearity of the compounds getting much better, okay, the melting point will increase as well. All right, so this could be due to the better packing of the molecules, all right, in their lattice, okay. And the same thing also happened on the tetra methoxy groups. All right. So when you look into sp11a, which is a more linear compound, it gave a better packing. All right, in the system, so it showed the highest melting point. So the dimethoxy stabile derivative also showing the same trend, in which the sp16 is the most linear. Okay, and you can see that due to its perfect linearity, okay, it gives a very high melting point, over 200 degrees Celsius. If you look into all of the hydroxylated stabile derivative, okay, all of them actually showing quite a very high melting point, over 200, okay? And the same observation also happens here when the linearity of the structure increase, all right, the melting point increase as well. Example, we look into the if you look into the SB4B over here, and its melting point is around 240 compared to the others, and the highest here is a SB12B. All right, linear compounds, and its highest due to the presence of much more hydroxyl groups. Okay, that will promote a more intramolecular hydrogen bondings. Okay, between or among the molecules that will give the high melting point in this compound. And if you look into the FTIR spectrum of the alkoxylated compound, okay, all of them show the similar patterns. All right, we have the, especially here, okay, showing the presence of the alkoxylated group, the sp2 carbon oxygen stretching at around 1200, and the sp3 carbon oxygen stretching, okay, right, this one, okay, here's the one that around 1000 with number. And of course, if we notice sp2 carbon hydrogen bending, that denotes the presence of the trans binary groups over here. And just want to point out the successfully hydroxylated stable derivatives show a broad, intense bands, okay, around 3200, centered around 3300, okay. And this denotes the hydroxylation, the conversion of the alkoxy group to the hydroxy group is being carried out successfully. Okay. Graduation being done on the stable derivative by using the normal proton NMR and the carbon-13 NMR as well. Okay. And for all the alkoxylated stable derivative, they show peaks at the alpha regions, which denote the presence of these what's so called alkyl groups on the alkoxy chain. Okay, and then again, when you look into the coupling constants of these two olefinic proton, okay, it shows the coupling constant of 16.5. Again, it shows the presence of the trans isomer of the stable derivative. And just for example, over here for compound SB1A, in which the B ring is a 1,4 substituted B rings. Okay, I will not discuss in deep in this case. All right, and the substitution pattern on the A ring and the B ring, we look into their splitting pattern as well as the coupling constants between the coupled proton. Okay, the same thing also being discussed, okay, on the tetra methoxy substituted stabines. Okay, so we have all this. This is actually a symmetric compound. Okay, so that's why we don't see much proton peaks. Okay, and we have all the alkyl protons at the alpha regions. All right, and then due to this symmetrical structure, all right, we only show one type of dynamic protons, okay, without any splitting, okay, at around 6.75. Okay, and against the assignments of the protons, okay, on the A and B rings, okay, is being done by referring to their spin patterns, okay, as well as their coupling constant between among the coupled proton. Okay, so the same also happens on this dimethoxy substituted stabine. Okay, so want to point out here is like, if you look into the coupling constant of these two olefinic protons, which is 16.5, so it shows that it's a trans isomers. So most of the this slide showing the example of successful conversions of the alkoxylated stilbene derivative to its hydroxylated stilbenes. Okay, after the conversions, we don't see the presence of these alkyl groups from the alkoxy. Okay, we don't see anything here in the other regions, and we notice there are three over here. There are three humps, small humps, okay, representing the presence of the hydroxyl proton, okay, H3, H2, H3, and H4 primes over here. Okay, and other than the normal one-dimensional 2D NMR, okay, 2D NMR also used to help in assure or in the confirmation of these what is so-called assignments of peaks for the proton and as well as the carbon of the synthesized compound. Okay, allow me to go into the vessel activities screening of the synthesized stilbene derivative. So the vessel dilation investigations is being done by the in vitro aortic rings assay. All right, in which that this is the schematic drawing of the device. Okay, and this is the aortic ring. Okay, in which we remove it from the rats. Okay, from the rats. All right, and I'm not going to go through the details of this experiment because it's done by my colleagues in School of Pharmaceutical Sciences. Okay, but what you can see here over here is like you get a different results of Rmax. Rmax is a maximum relaxation value on the tested compound. Okay, in which it shows the endothelium intact isolated aortic rings. Okay, that responds towards the synthesized compound. Okay, so and from the Rmax value that we obtained on all the 25 stilbene derivative as well as the stilbenoids, okay, and we compare with the Rmax value of the positive control, the resveratrol. So if we convert this table into the chart over here, okay, we can see that there are a lot of compounds showing the positive value, okay, over here, a positive value of Rmax, which indicates this compound showing the vessel relaxation effect, the widening the blood vessel, okay? And there are also certain compounds that showing the opposite effects by having the negative value of Rmax, which is denote the vessel constriction. It doesn't dilate the blood vessel, but it constricts the blood vessel. But one more much interesting get our attention is this particular 4 compounds, okay, which showing the higher Rmax value, all right, compared to the positive control, resveratrol, all right. So these are the 4 compounds, okay, and most of them are hydroxylated stilbene derivative, but only one sp11 here, A here, is the alkoxylated stilbene derivative. So it shows that these 4 compounds could be much better candidates, okay, compared to the currently market available resveratrol, all right, that will behave as a vessel relaxant, especially SB6B here. This is one, okay, in which it shows the almost twofold of Rmax value compared to this RV, the resveratrol. So from this,
excuse me, Dr. Au, is it
yes,
still some more? No.
This will be my last slide.
Okay, good. Thank you. Yes.
Thank you both today.
Yes.
Okay. So from this preliminary analysis here, we can draw some very preliminary SAR analysis. Okay, we're showing that compound having the hydroxyl group substituents at the 3-4 positions will actually give a good or better vessel relation effect compared to the RV, the resveratrol. All right. And if you look into compound 5A over here, this is 5A. right, is actually the analog of the RV, in which you see that this RV, and 5A you see that the hydroxyl groups on the RV over here is represented by the ethoxy groups. Okay, so it show a weaker vasoration effect. This means that hydroxyl groups is quite important, all right, in triggering the vasoration mediated receptor. All right, and if the only compound that is not the hydroxylated stilbene is these methoxylated stilbenes, okay, with symmetrical structures, and it actually show a better effect, okay, compared to this analog, all right, which is the tetrahydroxylated stilbene derivative, okay, and it means that this particular compound 11A could be the better vasoresistance, okay, is the option, okay, is the option of the alkoxylated stilbene derivative to overcome the low bioavailability of the hydroxylated stilbenes. Okay, so this I would like to thanks to my research group member, okay, Muhammad Shahil, Ms. Tan Soin. So these two are actually my two students that are firstly working on the synthesis of these vasorelaxation drugs. Dr. Loh is my postdoc, okay, and I would like to thank also my colleagues from School of Pharmaceutical Sciences, Dr. Yaman Fai and Associate Professor, yeah, Dr. Yaman Fai and Dr. Tan Chu San, okay, both of them helped me to carry out the vasorelaxation study, and of course, this work is being supported by the grants by Ministry of Education Malaysia, and of course, we'd like to thank a big thanks to the organizing committee of the 4th ICCS, and also to both to Tik, yeah, for your kind invitation. Okay.
Okay.
Yeah.
Yes.
Okay. Thank you very much.
Thank you very much, Dr. O, for your really comprehensive works. I mean, that's really great. And is there any question from the participants? Okay, just one question from me. How about the Wittig reaction? Is it simple, or do you have any constraint in doing the Wittig reaction? I mean, the result, the yield is not really high, right?
You are right, Prof. Tik. From what we got about the Wittig reactions, okay, let me go back. The yield is actually roughly 50%, yes. Right? The highest yield for all these 25 compounds that we have brought on, the highest in most is like around 65%. Yes.
Okay. Is there any? Do you know why you have having difficulties?
We are not really studying on this, okay. But I think one of the reasons is maybe due to the steric hindrance. Okay. Right, steric hindrance of the molecule. Yes.
Yes. Okay. And I think Mr. Idam will ask you a big question, please, Dr. Idam. Dr. Muhammad Idam.
Okay, thank you very much for the interesting presentation. So I just talk about the synthetic aspect of your studies. Yeah, have you ever tried to evaluate the vasorelaxant of the how do you say, the so far you evaluate the E isomer? Have you ever evaluated for the Z isomer?
Oh, okay. In fact, the Z isomer that we obtain is in very small yield. Okay, it's very small yield. If comparing in terms of ratio, it could be like, let's say in terms of 100, it could be like 85 over 15. Okay, so only 15% of the Z isomer that we obtain, and after a few what's it called, a few level of purifications, the amount is too little for us to carry out this vasoresistance study. Yes.
Okay. Yes. Thanks, Idam. And then possibly Paris, my student, PhD students, please, asking some question.
I still have some question. If
yeah, Dr. O, this is my PhD student.
Yes.
Yep, Mas Paris.
Or perhaps you can design perhaps B-style pin by using dialdehyde in the Wittig reaction.
Okay.
Yeah, there's possibility, and actually we have the intention to try by using a much more, how to say, modern, okay, methods like hack reactions, okay. Which is much look like a fewer steps reaction synthesis method.
Yes, comparing the.
Yes, yeah, that is in our idea as well.
That's a good suggestion. Faris, is there any question?
Yes, thank you, Prof. Dr. Ho Chuan Wei, for interesting the presentation. The first question is why the synthesis of derivative stilbenoid is not direct from the derivative of hydroxybenzaldehyde or hydroxybenzoic acid. It is possible to reverse this synthesis of derivative stilbenoid. And then the second question is there is any in silico study about this anti-hyperactive, because it is very interesting if we can study like a docking or dynamica molecular, because it is like a new in Indonesia, such as the activity of anti-hyperactive.
Yes. Okay.
Okay. Actually, this is our very first initial work on this project. Yeah. So when we try to design the compound, okay, we take the resveratrol, okay, as our reference compound, okay, and then actually frankly speaking, we didn't think much about what kind of patterns that we want to go for. All right, we just grab whatever we have in the lab, okay, yeah, and then we just started with the synthesis. Yes.
Okay. Yeah, and the second one is about the in silico question.
Oh, okay. Yeah. So it's quite difficult to have the in silico studies, okay, and it's not like in silico study like docking study, okay.
Yes.
Yeah.
Docking.
Yeah, like docking study, because the reaction is not like the enzyme and ligands, okay. And if you look, anti-cancer, if you look into the pathway for this like vasodilation study, okay, it doesn't only involve one pathway. Actually, the pathway is a lot. It can, if not mistaken, I remember it's around nearly 20 pathway. There are nearly 20 pathway. Okay, so I did discuss with my colleagues from School of Mathematical Sciences, and in the end, we conclude that it is not suitable to do this in silico study, particularly for this investigation. Yeah.
Okay, thanks a lot. Really interesting, Dr. O. Possibly we have another times to discuss about your results. Thank you very much for your really nice presentations. Thank you very much, everyone who's already asking some questions. And now I giving back the time to the MC. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Associate Professor Oh Chuan Wei, for the great presentations, and thank you, Dr. Tuti Wahyuningsi, MSc, as the moderator. Ladies and gentlemen, there are a few sponsors which support this event. One of them is PT Teknolab Indo, and this is the introductions video of PT Teknolab Indo. Please enjoy.
Okay, ladies and gentlemen, before we proceed to our next program, I would like to remind the presenters participants to use their full name on the account used in accordance with the name during the registration. Participants are required to change the user's name by adding a parallel code. For instance, Adi Herman will be engaged in Gamma Room. Then he should change his username as G_Adi Herman. Now we are going to the second invited speech that will be delivered by Dr. Anna Artati, MSc, from Helmholtz Zentrum München, German Research Center for Environmental Health, Metabolomics, and Proteomics Core, Germany. This second invited speech will be moderated by Associate Professor Dr. Melati Khairuddin. Please welcome Associate Professor Dr. Melati Khairuddin. The time is yours.
Thank you, MC. Okay. Okay. Assalamualaikum and good afternoon, everyone. I hope everybody can hear me.
Waalaikumsalam warahmatullah.
All right. Thank you for still being with us. All right. So now I would like to introduce another invited speaker for this 4th International Conference on Chemical Sciences. So on behalf of the organizing committee, it is a pleasure to welcome Dr. Anna Artati. Yeah. So I think it is pronounced as Dr. Rerum Naturalium, is it? Dr. Anna? Okay. Doctor of Natural Sciences, right? Okay, so first of all, I would like to share a little bit about the speakers. Right. Okay, Dr. Anna Artati obtained her Bachelor of Science in Chemistry from Universitas Gadjah Mada in 1996, followed by her Masters of Science in Pharmaceutical Chemistry at Institute Technology Bandung in 2001. And later she managed to obtain another master's degree, which is the Masters of Science in Industrial Chemistry at Technics Universität München, Asia, Singapore, and Germany in 2005, right? Then Dr. Anna proceeded with her PhD at the Institute of Toxicology, Helmholtz Center, Munich, Germany, under the supervision of Professor Dr. Johannes Filzer in the area of toxicokinetic study. And she was awarded with the title Dr. Rerum Naturalium for her PhD in 2010. Dr. Anna's research field include the area of metabolomics, untargeted and targeted approaches, bioanalysis, and analytical chemistry. And her research work is a closed exposure system for mice, open exposure system for human, in vitro and in vivo metabolism, liver perfusion. And she is also expert of the analytical techniques such as UPLC, MSMS, HPLC, MSMS, GCMS, AS, capillary ion analyzer, and spectroscopy techniques. She also has publications on her work. Okay, a little bit about her experience. Dr. Anna started developing her working experience in 1997 at the Freeport-McMoRan Copper and Gold in Indonesia, right? After about a year, she proceeded her master's and PhD studies until 2010. Then she became the scientist in Helmholtz Center Munich, German Research Center for Environmental Health, Germany. She started at the Institute of Experimental Genetics until 2017, then at the Research Unit Molecular Endocrinology and Metabolism until 2020, and currently she is the head scientist of untargeted metabolomics at the Metabolomics and Proteomics Core. So I hope that is correct, Dr. Anna. Okay, and without further ado, I would like to invite Dr. Rerum Naturalium Anna Artati to share with us her work. Welcome, Dr. Anna. The floor is yours.
Thank you very much for the kind introduction, Professor Melati. So I was informed by the organizer that they will present my video. Is that correct?
That is correct.
Hold on,
we are going to present your video.
Okay, okay. Then I will mute, and then later on I will turn on my audio on question and answer session. Thank you for the invitation to having me in this fourth international conference on chemical science. Briefly about myself, I am a scientist, work for metabolomics and proteomics core at Helmholtz Center Munich, German Research Center for Environmental Health. I am chemist by training. Helmholtz Center Munich is located in north part of Munich. It is a member of Helmholtz Association of German Research Center, the largest scientific organization in Germany. Perhaps you hear more about Max Planck Institute or Fraunhofer Institute, but actually Helmholtz Association is the largest research institution in Germany. It is a union of 18 research centers with around 39,000 employees. Its research focuses on common diseases which develop from interaction of lifestyles, environmental factor, and personal genetic background, particularly on diabetes, allergy, and lung diseases. Helmholtz Center Munich was founded in 1960, and currently there are around 2,300 employees working at the center. Today, I am pleased to share with you some update on metabolomic study in health research. I will first briefly give you an overview of metabolomics, and then I will present some findings in metabolomics in health research. Metabolomics is one of omics technology which is developing rapidly in past decades. It is a comprehensive and systematic studies about all small molecules metabolites in organism. Metabolites are endpoints of all biological processes in organism, which represent a snapshot of current biological states because metabolites are sum of genetic features, regulation of gene expression, protein abundance, and external factors like nutrition, lifestyle, and environmental influence. Metabolomic studies can include identification and/or quantification of metabolites in biological systems, as well as a dynamic analysis of metabolites as a response of living systems to pathophysiological stimulation and genetic modification. Biochemical of concern in metabolomics are metabolites or biochemicals that molecular masses ranges around 80 to 1,000 Dalton, including amino acid, carbohydrates, DNA binding molecules, lipid compounds including fatty acid, cholesterol, phosphatidylcholine, etc. Around 40 to 50 years ago, people started to have great interest on research in genomics, transcriptomics, proteomics to understand the genomes, gene function, and mutation in organisms. But eventually, it raises another need to understand the phenotypes in biological systems, like to characterize how organisms using their energy in their system, or to get a picture on how biological state of organism. For that, an understanding about functionality of metabolites in organism is required. As an endpoint of all biological processes in organism, Metabolites best represent the molecular phenotypes of organisms. Metabolomic workflows, including experimental design, sample collection, sample preparation, mostly solvent-solvent extraction, analytical analysis, data processing, identification, quantification of metabolites. There are two types of approaches commonly used in metabolomics. The first one is targeted metabolomics, when we are interested only in certain biochemical compounds. The second one is non-targeted metabolomics or untargeted metabolomics, where the goal is to provide as many metabolites as possible. There is no single optimum analytical method to cover the detection of all metabolites in biological samples. The most common technique used in metabolomic studies are mass spectrometry, or MS, which can be coupled to LC, liquid chromatography, like HPLC, UPLC, or gas chromatography. Another technique commonly used is nuclear magnetic resonance, or NMR. All of these techniques are complement to each other. With MS technique, we can get broad spectrum of metabolites, good sensitivity, high throughput of analysis, less biological metric effect. Whereas using NMR, we can analyze samples with higher reproducibility, but less sensitive compared to the MS technique. Metabolomic facility at Helmholtz Center was established not only to support research at Helmholtz, but also research in Europe and worldwide. It is an LC-MS-MS-based analytical technique equipped with automatic robot for sample preparation to ensure the quality of sample handling and processing. At our platform, we process various biological sample matrices from human and animals, including biological liquids like serum, plasma, and urine, as well as tissues and cell culture. Metabolomics has application in various fields, including health science, like the study about disease biomarker, pharmacology, drug discovery, and currently metabolomics also contribute a big role in the development or personalized medicine. Metabolomics is also applied in toxicology, and not only in human and animal studies, metabolomics is as well applied in plant research, like plant biotechnology, like to improve crop quality and quantity, and as well as in transgenic research. Simple application of metabolomics in health area was already there long time back, like when ancient Chinese and Egyptian evaluated urine to monitor the glucose level of diabetic patient around 4,000 years ago. However, the modern metabolomics was established when Robinson and Pauling used chromatographic separation to evaluate chemical constituent of urine in 1971. How is then correlation of genes, genomics, and metabolomics? How does gene penetrates into biological relevance? People may wonder why some can eat anything without gaining weight and some other are struggling to keep their figure slim. Why? We know that genes influence phenotypes, but genetic is not the only answer. Besides the genes, the state of our being is determined as well by other factors like what we eat, what we drink, whether we take drug or not, whether we smoke, how is our lifestyle, whether we do exercise regularly, and as well the composition of gut microflora. But all of these factors connected to phenotypes, for example, to how these all factors connected to our health state. It is metabolites that intermediate the connection between genes, external factors, and phenotypes. The pathway map you see here is a kind of imaging technique to understand how metabolites connected to each other. All the dots here represent the metabolites with various functionality in metabolic pathway, for example, like carbohydrate, lipid, amino acid, energy, and nucleotide metabolism, and the line represent the enzymatic and transporter reaction. Genome-wide association study, or GWAS, is an observational study of a genome-wide sets of genetic variant in different individuals to see if any variant is associated with a trait. GWAS study have identified a number of genetic polymorphism that associated with an increased risk of developing common diseases like cardiovascular and diabetes. Epidemiological study shows that external exposure like lifestyle, nutrition, as well as gut microflora contribute to the development of complex diseases. However, by only associating genotypes or lifestyle with clinical outcome, in most cases, the disease-causing mechanism cannot be completely explained. Metabolites as an intermediate phenotypes contribute to solve this problem. Information about metabolites provides more information on potentially affected pathway and to be more directly related to the etiology of the diseases. It provides a functional readout of physiological state of human body. The first study on the correlation of GWAS and metabolomics as intermediate phenotype was done by our group at Helmholtz. In this study, GWAS and metabolomics analysis of serum of around 284 male participants of a CORA cohort was conducted. CORA cohort is human cohort in Augsburg, Germany. Even though it was a small study, the effect of genetic variants is very obvious, so that a lot of information can be drawn between GWAS and the intermediate phenotypes and between metabolites and the end of the endpoint like our disease. We know from genetic profiling that in population there are genetic variants or SNPs. There are people carrying homozygote with mature allele, heterozygotes, and homozygote with minor allele. The gene regulate biological reaction in the body. With metabolomics, we understand how genetic variants influence phenotypes. Let us have a look. In one example here we found in this study, namely fatty acid denaturase 1 or FADS1. FADS1 codes the fatty acid delta 5 desaturase, a key enzyme in the metabolism of long-chain polyunsaturated omega-3 and omega-6 fatty acid. For example, it catalyzed the formation of arachidonic acid, a precursor of prostaglandin, a biochemical which play a key role in generation of inflammatory response. Metabolomics data showed that the concentration of arachidonic acid in individual carrying homozygote minor allele were significantly lower than that of individual carrying homozygote mature allele, as you see in this box plot. People carrying homozygote mature allele produce higher level of prostaglandin, and they are categorized as fast metabolizer. People carrying heterozygote or medium metabolizer, and people carrying homozygote minor allele are slow metabolizer. So it means that metabolomics correlate with genetic variants. This is only example of one gene, what I show here. We know that in human body there are thousands of genes, and each of them regulates certain biological reaction in the body. So you can imagine how complex genes through metabolites build up the metabotype individuality. After having a brief review on genetic and metabolomics and the importance of their association, let us walk through with more focus on human health, particularly on metabolic diseases. Metabolic syndrome is the cluster of risk factors like oxidative stress, insulin resistant inflammation, hypertension, low level of high density lipids, and high level of triglycerides that together culminate in the increased risk of type 2 diabetes, cardiovascular disease, or stroke. Now let us look into worst case of metabolic disease I would like to address, which is type 2 diabetes. Every one of us know the significance of diabetes in the society, everywhere in the world that we must fight for. In 2017, there were around 400 million people live with diabetes, and estimated it will increase around 50% in 2045. In Southeast Asia, around 82 million people living with diabetes, and it will increase to around 150 million in 2045. This is World Atlas with color coding of number of people with diabetes. The dark blue indicates high numbers of people with diabetes like Australia, Asia, and North America. When people talk about diabetes, normally they refer to glucose level and on perturbation on lipid homeostatic like triglyceride, cholesterol, and non-esterified fatty acid for diagnosis of diabetes. However, application of metabolomics has led to a broader recognition of metabolites that associate with diabetes and even that predict future disease development. Some studies have identified dysregulation of metabolism of branched-chain amino acids, which is leucine, isoleucine, and valine. Also aromatic amino acid, which is phenylalanine and tyrosine, glutamic acid or glutamine, methionine, and C3 and C5 acylcarnitines in subject with obesity and insulin resistance as measured by the HOMA-IR score. The finding was also confirmed by several studies, like the study done by Tay-Eas et al. In this study showed a clear association between the subset of amino acid and insulin resistance in Chinese and Asian India individuals living in Singapore. Strong association of the subset of amino acid with insulin resistance was also confirmed in multi-omics, in multi-ethnics, including European American, Hispanic, and African American. So it means that it is proof that the same biomarker was found in multi-ethnics. The second case of metabolomic disease, which is also very important that I would like to highlight, is cardiovascular disease, one of the diseases which leading to the cause of deaths and morbidity worldwide. We did a longitudinal cohort study which was published in Circulation Journal in 2015. Blood sample of more than 13,000 apparently healthy people from 3 cohorts in Finland and UK were screened, and the health status of the volunteer were followed for over decades to look for measures in blood that could reflect who had suffered a heart attack or stroke within the following years. From this study, we found 4 biomarkers were indicate the future cardiovascular disease risk independently of known risk factors, such as high cholesterol and elevated blood pressure. Higher concentration of amino acid phenylalanine and monounsaturated fatty acid were strongly predict the future heart disease. Higher concentration of metabolites which links with higher risk disease. High level of omega-3 and omega-6 fatty acid were linked to lower risk of cardiovascular disease. All of these molecules are normally present in everyone's blood, but it is the amount of the biochemicals that was shown to be reflecting the future cardiovascular health. With this, I come into end of my talk. These are people in our core facility, and here is Christian Kicker and Karsten Sure who did the GWAS studies. I would be happy to answer your question if any. Thank you very much.
Okay, thank you, Dr. Anna, for such an interesting sharing. Now I would like to open the questions and answer session to all the participants. Wait, let me check the chat box. Okay, no question in the chat box. Okay, is there any question for Dr. Anna? It seems that everybody is very shy. Or maybe they are still compiling some questions. Okay, if there's no question, maybe I can ask a question to Dr. Anna. Dr. Anna, how is it during the COVID time? The handling of the samples and all that, is it very, you know, you're really involved in that, or is it like the cannot do anything during the COVID time?
Yeah, of course, in COVID time is a difficult situation for all of us, and even currently German has a high again. We have again high number of COVID, infected COVID patient right now. Of course, it's difficult situation, but and most of people working here at Helmholtz also suggested to work from home, but we managed anyhow to continue with the research. So it means that not everybody is stay at home. So of course we have a schedule who can work in lab and so on. So the thing is that we only need to organize. But yes, the pace is not as the speed is not as high as before the pandemic, but still we have continuing research, of course. And Helmholtz is one of the institution in Germany which involved very actively, and one of the partner of the German government on COVID research, and our virolog also involved very much on the COVID research in Bavarian government. Yeah.
Okay. So until now, it is still ongoing, some of the research, right?
Exactly. Of course, the pace is not as high as before. I mean, of course, there are some delays, but it's still ongoing. Yes.
So how is it like nowadays? Because they say it's like there will be another wave and all that in the European countries. So is it like becoming better, or is it there's a wave?
Yeah, I mean, better, not better right now, of course, but the government working to overcome that. But yeah, I mean, this is currently in Europe. I mean, not every Europe countries, but some of Europe country, including Germany, is suffering currently. Yeah.
Okay, so thank you very much, Dr. Anna. Let me check again the chat. Okay, so for the participants, if you have any questions or anything, you can they still like contact you through email, things like that, Dr. Anna?
Yeah, of course, yes.
Okay, so you can always email. Okay, you can always check from the, I mean, if you check in the Google also, Dr. Anna will appear there, you know, like, okay. So thank you very much, Dr. Anna. So
thank you, my pleasure.
I pass back to the MC. Okay, thank you.
Thank you, Dr. Renat Anna Artati, MSc, for the great presentations. And thank you, Associate Professor Dr. Malatika Herudin, as the moderator. Ladies and gentlemen, there are a few sponsors which support this event. One of them is Indonesian Natural Dyes Institute, Universitas Gadjah Mada. This is the introduction video of them. Please enjoy.
Gadjah Mada University is a world-class university that is a pioneer of world-class national universities that are superior and innovative, serving the interests of the nation and humanity inspired by the nation's cultural values. Gadjah Mada University has a mission to carry out education, research, and community service as well as the preservation and development of superior and beneficial knowledge for society. UGM has 18 faculties and 2 schools that organize undergraduate, postgraduate, professional, specialist, diploma, and international programs. Actively, lecturers in each faculty make real contributions to national issues and support for realizing national sovereignty. One issue that needs to be raised and addressed is natural dyes. The existence of Indonesian natural dyes is currently not optimally developed and utilized properly in Indonesia. In addition, activities related to natural dyes through research and development are also seen as not having a major influence on the development of natural dyes in Indonesia. Whereas, research and development of natural dyes has many aspects, ranging from cultural aspects, cultivation of natural dye producing plants, natural dye production technology, product coloring technology, economy, and social. Therefore, Gadjah Mada University answered the challenge through the multidisciplinary research group of the Indonesian Natural Dye Institute, INDI, UGM. INDI as an innovative leading higher education program continues to strive to participate in helping to solve the nation's problems in the preservation and development of Indonesia's natural coloring. INDI was founded on December 10, 2019 with the vision of being a means and reference for education, research, development, and procurement of natural dyes for a healthy and prosperous Indonesia. The following are the missions and indicators of the work of INDI UGM. Research and development of natural dyes. INDI UGM is a multidisciplinary field of science. The upstream section is a research on the search for raw materials, with an orientation to the discovery or reintroduction of natural dye raw materials in which the elements of chemical, cultural, historical, theological, substantive, and existing values are considered. Middle section includes innovative research concerning processes and technologies for the manufacture of natural dyes in textiles, food, and leather, as well as the manufacture of natural color pigments for various products for paint and screen printing, with research connections between one domain and another, such as the management of natural dye sources, technology, economy, and community culture. Downstream covers application research, both in the technology of dyeing fabrics, food, and leather using natural dyes. The technology here is both manual and mechanical, as well as to improve the quality of the natural color strength in products by taking into account the environmental, economic, political, social, and cultural aspects. As a commitment to achieving the SDGs in Indonesia, in the baseline research that has been carried out, INDI uses a comprehensive approach where programs are directed to have a wider and beneficial impact on society through the pentahelix cooperation, ABCGM, academic, business, community, government, and media. INDI's business partners include H&M Company and Marta Talar Company. Community partners, CSR, include UNESCO, BI, BRGM, Pusri Company, ITP Palamanan Company. Government partners consist of the Ministry of Industry and Agency for Regional Development, and media partners from the journalist team. INDI through the Matching Fund program collaborated with CV Karui to develop the utilization of sawdust waste in Jayapura, Papua to be processed into natural tannin dyes. Sawdust waste from the Merbau sawmill industry is available around 500 kilograms to 1 ton per day, which has not been utilized optimally. So far it has been piled up around the factory and burned regularly, thus disturbing the environment. In this first stage, only natural dyes are used. In the next stage, after taking the dye, the biomass can be processed into charcoal briquettes and liquid smoke, so that it has high economic value. Thus, a mini plant with a zero-waste system can be built, which is what the green industry hopes for. The results of this mini plant will be a successful model for processing Merbau waste or other forest product waste in Jayapura. Meanwhile, on a national scale, this Merbau wood waste processing production unit has become a prototype for other regions. Furthermore, the noble ideals of establishing the archipelago natural dyes ecosystem in Indonesia can be realized. In addition to the mini plant, INDI has also developed a fabric dyeing machine with natural dyes to support the industrialization of textile products through LPDP innovation research. The resulting technology is expected to be utilized by craftsmen in order to meet the demand for large capacity. In the community empowerment section, INDI has fostered villages in Samanu and Kampung Laut, Central Java. For craftsmen partners, INDI UGM has fostered greater than 40 micro, small and medium enterprises for songket, ulos, jumputan, and natural dye-based batik products. Last, the use of natural dyes is a movement that leads to four things, namely, safety, health, environment, and welfare. Gadjah Mada University and INDI comes with natural dyes will be the answer to the increasingly uncontrollable environmental pollution from the use of synthetic dyes, the answer to the declining health quality of business actors who are engaged in synthetic dyes in the long term, the answer to the importance of strengthening the identity and culture of the nation through its local wealth and wisdom.
Ladies and gentlemen, now we are going to have a parallel session. And after the parallel session, please go back to the main room at 3:40 p.m. Western Indonesia time. For those who join the parallel session, it will start shortly. So now you can proceed to your presentation room. Thank you.
Welcome back to the main room of this event. As for tomorrow's session, you can join the virtual room at 7:30 a.m. Western Indonesia time. All participants must present for the second day of International Conference on Chemical Sciences. Ladies and gentlemen, on behalf of the 4th International Conference Chemical Sciences Committee, we would like to say thank you for your participations and have a nice day. See you on the next day of the conference. Good afternoon and wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam.
Waalaikumsalam.